So why Django Rest Framework? Well, there are many reasons why you might use or learn Django Rest Framework. First is the browsable API, which is a huge usability win as developers can interact with the API through a built-in out-of-the-box user interface, which makes the development faster and the debugging easier. Second is the authentication policies, which includes the two packages, the OAuth 1 over HTTP and OAuth 2 protocols. And third is the serialization, which makes it easier to convert data between incompatible type systems. Fourth, it's very customizable and flexible, so no matter how advanced or simple your project, you can achieve it with Django Rest Framework. And fifth is the extensive documentation and great community where you find all the support you need. And sixth, it's used and trusted by internationally recognized companies including Mozilla, Red Hat, Heroku, and Eventbrite, plus many others. And we mustn't forget that Django Rest Framework was built on top of Django, which is a very powerful framework that has been in the market for more than 15 years with great documentation and support and huge community. And having a Django Rest Framework using Python as a programming language is a great advantage and plus point, because Python is one of the most popular programming language at the moment. And it's very powerful, which will allow you to do anything on your server side or API server, including implementing machine learning models. Hello everyone and welcome to my course. My name is Acer. I'm a self-taught programmer and an electronic systems engineer. With over 7 years of experience, I came to share my knowledge with you. So at the end of this course, you'll be able to build a robust API using Django Rest Framework. And that will be possible because you will learn and you will be able to handle user authentications like sign up, login, logout, and other functionalities. Plus, you'll be able to secure your API using authentication tokens and JSON Web Tokens and permissions. And you'll be familiar with Django admin panel, which you'll use it to store, delete, and edit data in the database. Plus, you'll be able to use the serializer to serialize sent and received data, plus handle the nested data and add independent and extra field to your responses. You will also be able to use functional-based views and class-based views to handle API functionalities, URL parameters, and data processing. Plus, search and filter data inside views using one or more parameter. Get full control over your API by overriding the actions inside view like create, update, put, delete, and other actions. Use Django relationships to link models and tables inside your database. And add to that, being able to use throttling to control the rate of request to your API. Improve your API performance with multi-threading and scheduling tasks. And at the end, being able to deploy your Django REST API online using Heroku and AWS. With that being said, I'm so excited to share this information with you guys and be a helping hand in your journey as a programmer. So see you in the course. Hello everyone, in this tutorial we will be preparing our development environment with all the necessary tools and softwares. So first thing first, we need to install Python because we're going to be using Python as a programming language for the Django Rest Framework. And to do that, we need to go to python.org website, downloads, and choose the operating system that we're using. For example, I'm using Windows. You can choose that you're using Mac OS or Linux. and then you choose the Python version. The latest one is 3.9.2 at the moment. We're going to be using 3.7.10, but feel free to use your preferred version. And if you come across any issue with or during the course, please leave it in the comment below, and then I'll be happy to help you. After installing the Python, we need to install text editor for our development, and for that I'm going to use VS Code because it's very handy and great software to use for development, and with a lot of features and options. So same thing, we need to go to code.visualstudio.com and downloads, then choose the operating system and then install it. The next software that we also will be using for API testing is the Postman. Okay, so we need to go to the Postman website, postman.com downloads, download the software, and we'll be good to go. I'm going to leave all these links in the resources of this tutorial, so you can just go there, install them, and then get ready for the course. I'm so excited, guys, to start this course with you. See you in the next one. Hello everyone, in this tutorial or series we're gonna learn how to create an API using Django Rest Framework. Let's get started. So first thing first, let's create a folder that will contain all our files. So let's name it my API. So I recommend using VS Code as a code editor, and it's a really nice software, and it's easy to use and will make life easier for you guys. So let's open this folder, with VS Code. So inside VS Code we can run a terminal. So inside the terminal we need to create a virtual environment. Virtual environment is very important. Why? Because virtual environment will contain all our packages and frameworks and the software that we need, okay, the packages that we need to build our project without interfering with other projects if we're using different versions or different libraries. So in order to install that, we need to install virtual environment. I had it already installed, so but if you guys want to install, just go pip install virtual env. After installing it, we need to create the virtual environment. So how we do that, we just type virtual env and we write the name of virtual environment that we want. You can name it any name. I'm gonna name it env. So now it's preparing the virtual environment for us. As you see, I'm using Python 3.7. I assume that you guys had a Python installed, so I recommend using Python 3.7. So after installing the virtual environment files and necessary libraries, we need to activate the virtual environment. So how we activate the virtual environment? // we go to the directory which is env /scripts/activate. So as you see here, guys, we have a little env here between two parentheses. So this means that our virtual environment is activated, and anything we install now will be inside our virtual environment. So first thing first, Django Rest Framework works inside the Django environment, which means first we need to install Django. So let's do it. Pip install Django. So all our projects, all the work that we're going to do is inside Django. So first thing, we need to install Django. After installing Django, we need to create or start a Django project. So the Django project, inside the Django project, we'll build our API. So in this tutorial, after we install the Django and start our Django project, we will run this project, run the server, Django server, make sure everything works fine, and in the next tutorial we will carry on with the rest of API, building it, So it's installing now. It depends on your internet speed or the time that Django takes to get installed. So it's installing now. It won't take long. So as we see now, it's already installed. So what we need to do next is start a Django app. So how we do that? We go Django admin start project, and then we name the project that we need to, whatever name you want to. So let's name it my API, because we're gonna build an API. So as we see here, this created a Django project with the project files inside. Django created all that for us. So what we need to do next is go inside the directory of the folder my API and run the server. So how we run a Django server? We just go python manage.by, which is this file that will manage most of our operations inside Django. Run server, and this will run a Django server. As we see here, Django created a database file using SQLite. SQLite is a database where the Django stores tables that already being created inside Django project. So, and if we notice here, it says we have 17 unapplied migrations. So unapplied migrations or migrations, we will talk about it later, but for now all you need to know that migrations is related to your database tables. So if you create a new database structure or a new tables, you need to run migration in order for Django to connect the database together and create the necessary files. So in order to do that, Ctrl+C to close the server, and we need to run the migration. How we run the migration? We just go python manage.by migrate, and as we see, we did all the necessary migrations for now. And let's run the server again. As we see now, there's we're not getting the same message that we got previously. So, and it's telling us starting development server at localhost. So if we go to this localhost, we'll see that our Django server is running successfully. So what we need to do next in the next tutorial is create a super user and get access to the Django admin panel. So we can see more about Django and work inside the environment and go forward with our API building. And thank you guys for your time. Hello everyone, in this tutorial we will see one of Django features that comes out of the box for us to utilize and use, and it's pretty handy and useful when developing our Django projects, and it is the admin panel. So if you come here, if you check last tutorial, we created a Django project. So if we explore the files here, we can see that we have like some pre-built files they created when we created the project using the admin or the Django admin comment. And inside here, if we go to the urls.py file, which represents the URLs that our project will serve, we see here that we already have a URL or a path called admin. And in order to see or check that, let's first run our server. So if we open the terminal, inside here, before running the server, let's first activate the virtual environment. So we do it as we do it usually, then space // and then we put the folder of the virtual environment, and then script, and then activate. And after we see this env here, we know that our virtual environment is activated. Now we can run our server. So we simply type python manage.py run server. And now the server is running, but I have some migrations here telling me you have 18 unapplied migrations. So guys, if you have, or if you see this message here, just simply close the server by just Ctrl+C, just pressing Ctrl+C, and then run the migration. So how we run the migration? First thing first, we do python manage.py make migrations. Yeah, I misspelled it. And then we migrate. So python manage.py migrate. And as you see here, all the migration is getting applied. So now we can run the server. And if we go to this link here, which is the local host, we see our server is running. What we need to do is we need to navigate to this path here, and we'll see what we'll get. So if I go here and type admin, it'll ask me to log in, to provide username and password. At the moment, I don't have a username and password to enter this panel here. In order to get this, we need to create a super user, or in other words, an administrator. In order to do that, we come back here to our terminal, we close the server, and then we type python manage.py create super user. So that will ask me for username. Let's name it admin, and then email address, let's just say admin@myapi.com. .com, for example, and then we add the password. I'm typing the password, but it's hidden. You won't see it on the terminal. And that's telling me now that super user created successfully. So if we run the server again, and then go to the admin panel here, link and provide the credentials, admin, and the password. As you see now, we're logged in, and this is, guys, is the admin panel that Django provides. And as you see now, we only have two options. One users, the other one is groups, and that's because we don't have any applications yet in our Django projects. And each application we create or we start in our Django project, we can add it to the admin panel, and that will give us a lot of flexibility in terms of testing and managing our project without having to build an administrator panel where we can insert, delete data and all that stuff. So if let's check, for example, users here. If we go to users, we can see that I have here the users that I created. I can simply add another user here by just typing the name, for example, user1, and then adding a password here. Just verifying the password, and then save, and this user will be saved, and it'll take me to another interface here where I can add more information about the user and some permissions, and all that comes out of the box. I didn't have to code that, I didn't have to configure that. All that is ready for me from Django, and then I can simply save it, and I'll have here a new user. Okay, I can also create some groups and add users to it. So for example, here, if I go add group, I can just name, for example, group 1, and each group will have like some permissions, or some limitations I can specify here and add to the group, and I can then add users to that group. For example, if I choose for example this one and add it here and then save, now I have a group here, okay, where I can, if I go back to users, for example, user 1, you can see here that I can add user 1 to a group 1, for example, and then the users that inside this group have certain permissions and limitations. So all that I can do from Django admin panel. So for this tutorial, I just wanted to show you the Django admin panel, because we are going to utilize this in the future when we create our apps, adding data, deleting data, and all that stuff. And you'll see how easy to use and handy is admin panel. So that's it, guys, for this tutorial. Hope it was useful. If you have any questions, please leave them in the comment below, and until the next one. Hello everybody, so today we're gonna create or write our first model or data table. Okay, and I was thinking about, let's create something that will give us, we all love cars, so let's create something that will store some cars specs. Okay, so we open inside our API or my API app. Okay, we go to models.py, and here we start writing the code for our table as a class based model. Okay, so we start by class, and then the name of the class, let's say car specs. Okay, car specs. Okay, and we need to we need to import here or inherit some functionality from models dot model, okay, which we imported here. So after that we start creating our table fields. Okay, so what we really need to store about our cars. Okay, what specs? First, let's start by brand. Okay, car brand. So car brand is the field. We need to tell our server or our Django model what type of data is going to be stored here. So we start by models dot, I think it's going to be string and it's not going to be long, so the best thing to choose char field. This is character field, and we need to put some, I mean this takes a lot of arguments here, but what we need to put now, which is enough just to put some specification, is a max length. Okay, let's add a max length. So we'll tell our table this is the maximum length for this field. Okay, we're not going to talk about all this here. For example, blank, false, blank, null. This will make, it's like this, those are kind of specifications or configurations, restrictions, all of that are here. So like if we choose blank and false, if when we store data here or when we send data to the table, if this field is blank true and null true, okay, then it will be accepted. If it's blank false, null false, that will give us an error. Okay, like a server error or no bad request error. Okay, so we're not gonna talk about these restrictions at the moment. We'll have another tutorial for all that. For now, let's just do max length and how many characters the brand would be. I don't think it's gonna be more than 50. So 50 is enough. What else we need to add? We need to add car model, and it's going to be the same. Char field. Okay, model can be maybe longer, so we allocate like 100 characters for it. What else can we add? Production year maybe. Okay. And this also can be a chart field and can be a string. Okay, although it's a year, but it's okay. And maybe let's check one site here that I found and see what else can we do about car. Okay, so this car, yeah, we can write car body type. Okay, let's go here. Just trying to create some useful fields here. Okay, what else can we add, do you think? Maybe it's enough, but I'd like to add like engine type, for example. This is a engine type. Okay, so I think that's enough for now. I think those fields will be enough for us, to see how we manage our model, how we store data in it, how we get the data from it. So let's save that. As we know, or as we spoke about in previous tutorials, a model in a Django application, it's like a table, okay? A table means it's a database, okay, that formed or formatted in a table, okay, which has fields with columns, like that. Okay, you can see it like that. And after we create any kind of table or database in our models, we need to do something to make our server acknowledge, okay, or format this database in such a way that will be stored in like an SQL form, okay? It will be like translated from model, okay, class-based model, into a normal database like SQL, PostgreSQL, MySQL, or SQLite. So normally what Django uses in the local host is SQLite, okay? So how we do that, okay, how we store those fields as a schema or as accessible database in our server. So we do that through migration. So after we write our model and our fields here, we create our table, we need to run the server and run migrations, okay? Make migrations and then migrate. So let's do that now. Let's open the terminal. Let's clear this and activate our virtual environment. Okay, let's navigate to our application, project folder, and let's run the server and see if the server will give us a message telling us there's some data need to be migrated or something like that. Python. Okay, it didn't give us any message about the data because it's not a new app, it's within the app that we already created. So we know that after we create any model, now we need to run the migrations. So what we run first is Python manage.py make migrations, and if you look here, after we run make migrations, our server or Django server create model car specs. So after that, now we run migrate. Okay, so migration has been applied now. So how can we access this? We don't have any view, okay? to deal with our model that we created, and how we're gonna store data in it and see what's stored there. So before creating a view to deal with that, let's add this table to our admin panel so we can access those fields there. We'll be able to add and delete and see what's in our database as an admin. Okay, so to do that, we come to admin.py, and here first thing we import our model. So from .models, which is this file here, we import car specs, which is the model. Okay, and then what we do is we need to we need to register this model in our database. So what we do is we write admin.site.register, and what we're going to register, we're going to register the car specs. We save this and we run our server again. So let's go to our admin panel now. Okay, this is the admin URL, and inside the admin panel we need to see something called car specs. Here we go, this is it. Sorry. So this is the car specs. If we click here, it takes, there's no data yet. Okay, so there's 0 data. So we have here something called add car specs. So we can come here, click on this, and you see here, can you see guys, here we got the fields that we can fill. So let's add some car specs. For example, let's get this. This is the brand, we know it's a BMW, and it's 740. So the car brand is BMW, model is BMW 740i, production year we can check here, 2019. Car body, the car body is 4 doors, sedan. Engine type, fuel engine. Okay. So what's next? Now we can save this data. If we click save here, you will see that we have a new car specs object. Okay, what if we need to change this not to show here car specs object, because by looking at it like this we don't know what's inside. So we can change this from our model by using a function, a reserved function called string. So if we write here, we write the string, str I mean, and we need this function to return, this function must return a string. Okay, so what we need this function to return? We need this function to return, for example, the car brand. Okay, so we know that this car, when we look to our database there on the admin panel, we know this is a BMW, so we just need write car model or car brand, I mean. Okay, we save, we wait for the server to rerun, and if we go now here and refresh, Well, it says name car brand is not defined. Okay, because I did a mistake here. So in order to access the car brand, which is in the main class, we need to use self, the reference self. Okay, that's it. We save. We wait for the server to run. Come back here. We refresh. And as you see here, we got BMW. Okay, so let's add another car. We can add as many as we want for now. So what else do we have? Let's add this Mercedes, for example. So this is the brand. Okay. And this is the model. Year of production I think is 2019 also, and it's fuel engine. So 2019 fuel engine, I think 4-door sedan or something else. Yeah, it's the same. So we can save, and as you see here, we got another car, which Mercedes, and if we click here, we get to see all the specs, and we can delete or we can edit and save. We do whatever we want with it. So that's it for now. That's it for this tutorial, guys. With the model, we learned how to create a model, create some fields, add it to the database, add some data to it through our admin panel. So in the next tutorial, we're gonna work with views, and we're gonna create a view that will deal with it, so we can access the data and send and receive and add through our API endpoint URL and within our browser. So that's it for this tutorial, guys. Thank you so much for your time. Hello everyone, in this tutorial we will see how can we implement Django-Rest-Auth in our Django Rest Framework project in order to handle user registration and authentication tasks. So Django-Rest-Auth is very handy and powerful for handling user tasks like registration, activation, authentication, login, logout, change password, retrieve user information, edit user or update user information, plus social media authentication, because it provides a bunch of endpoints that we can use through our front end to perform all user processes or tasks. So let's start by installing the Django Rest-Auth, and here is the documentation. I'll leave a link in the description. It's very easy to read, easy to implement and to use. So let's go to installation, and to install it we're going to use pip. So I'm going to copy this and I'm going to open the project, the Django project, in VS Code, and inside here, first thing first, I'm going to activate the virtual environment. So // and then the virtual environment folder, which is vm, then scripts. If you are on Mac, replace script with bin, bin, and / activate. And as you see here, we have vm between parentheses, which means our virtual environment is activated. Now we can install the Django Rest-Auth, and after that we need to do the necessary configurations in our settings and urls.py in order to be able to use the Django Rest-Auth. So I'm going to go back to the documentation. Inside here, the second step is to add the Rest Framework Auth token and Rest Auth to the installed app. So we're going to do that. And we go to the installed app here, apps, and then we paste these two applications, and then we save. And after that, we need to add the endpoint or the main endpoint for the Django Rest-Auth into our URL patterns inside urls.py. So I'm going to copy this, and I'm going to go to urls.py. Inside here, I'm going to add the Rest-Auth. So I'm going to convert this into normal path. This is a path here. And that's it for the URLs. I'm going to save it. And then I'm going to go back to the documentation. And because I installed two new applications here in the installed apps, I need to run the migrations. So let's do that. Just typing python manage.py migrate. And we'll see that 3 migrations happened. The auth token, which is, we will see what is token in a bit. So let's head back to the documentations and see what we need to add. After that, in order to perform registration, like user registration, we need to use or to install Django-Auth, okay, all auth. And after that, we need to add some extra application to the installed apps. So let's do that. We need to install Django all auth first, so let's do it. Pip install Django all auth, and let's leave this to install and go back to the documentation. We need to add these applications plus the site ID to our settings. So I'm gonna just copy them and then go to the settings.py, okay, and add these apps here. And then I'm gonna add down here the site ID equals 1, and then I'm gonna save it. And let's go back to the documentations and see here, in order to perform registration, we need to add an endpoint for the Rest-Auth, which is Rest-Auth registrations. So I'm going to copy this. We already have the Rest-Auth, so what we need to do is add the Rest-Auth registration. So I'm going to go back to urls.py and I'm going to add it below here. I'm going to convert this to path. You can keep it as URLs, it will work as well. I just want to keep things neat here and save it. And then, and for social authentications like login with Facebook, with Twitter or GitHub or other social media platforms, we need to install some extra applications here and also add some extra endpoints, but we're not going to talk about this in this tutorial. We will leave this to future tutorials, and in this tutorial we will stick into main Django Rest-Auth registrations and authentications. So after doing this, I think we are ready to migrate again, because we added some extra apps, and then we will test. So let's do that. So inside here, we'll clear this, and then we will run the migrate. and it's asking me here, says no module rest auth Django, and that's because I forgot to add a comma here. So I'm gonna add it, save, and then run the migrate, and it should work. And as you see here, all migration have been applied. Now we can run the server and just try the new endpoints that we added from Django Rest-Auth. So I'm just gonna run the server. And now that the server is running, I'm gonna go to the browser and let's go to the localhost. As you see here, I have Rest-Auth and Rest-Auth registration. So if I go to Rest-Auth, as you see, if I go to Rest-Auth, all these endpoints are available for me. And as you see here, we have password reset and what password reset confirm. And we have the login, logout, user, and password change and registration. So we need to try first the registration, and we use that to sign up a new user into our API. So let's use that. So we're gonna add here registration, and as you see, this will allow me to add a new user here by adding the username, email, password 1 and password 2. And if you look at the documentations and go to API endpoints, as you see here, for the, if we scroll down to the registrations, as you see here, it says it's a post request to this endpoint, which is Rest-Auth registration, and this post request should include a username, password 1, password 2, and email address. Password 2 is a confirmed password for the password 1. So password 1, password 2 must match. So if we go to the endpoint and we add a username, like for example Mark, and we'll choose the email address mark at my API, and we'll choose a password, for example, and we confirm the password, and then we hit the post button. And now the server is processing, and it gave me an error saying no connection could be made because the target machine actively refused it. Don't worry about this error. I think this error is, we're getting this error because we're performing it from the browser. But in a real life scenario, you're going to be performing this from your front end framework, and you won't get this error definitely. So in order to confirm that the registration is done, let's go to the admin panel. So I'm going to go here to the admin and then log in, admin, and then I'll provide the password. And if you look to the admin panel now, you can see some changes here happening. And one of the changes, or the new fields that we see here, is the tokens. And what is that basically? Tokens are like unique keys that get associated to users when they sign up. So when a user signs up or registers in our API, a unique key gets generated and allocated to that user. So we can use this unique key or token to authenticate the user while performing requests to the API. And if we look to users here, we can see that I managed to register a new user with the name Mark, and if I click on it, I can add or edit information here about this user. And if I go back to tokens, I can see that I have a token here, a key which is linked to Mark. Okay, so this is the whole registration process that you need to do in order to register a new user in our API. It's simple and easy to implement. So now that we saw the registration, let's check the other endpoints. So we'll go back to REST Auth, and we go to, for example, login. Okay, so if we do login, we can see that this form here asks me to enter username, which is, for example, Mark, that we registered, and I can enter the password, and then I click post. I didn't have to provide the email. So as you see, the API returns the token key after we perform the login. So in your front end, you ask the user, for example, to provide the username, password, then you perform a post request to the API, and the API returns a key, which is the token key, and then you should save this key in your front end, and whenever this user perform a request to the API, you need to implement or include this key in the request header as an authentication header in order to authenticate the user if necessary. And to log out, I can simply perform a logout by using the logout endpoint, by typing logout here, and then perform a request. And as you see here, I have this form. If I perform a post to the logout, you see that I'm logged out now. So as you see, guys, Django Rest-Auth made it very easy for us to handle user registration and authentication through our API, and it's also pretty easy to do this through our front end if you're using Angular, React.js, or normal JavaScript. So if you check the endpoints here, so we use the login, logout, and we use the registrations, the registration request. The rest of the requests we're gonna see or we're gonna try in future tutorials to be able to use all the functionality of Django Rest-Auth and take advantage of it in real applications. So for example, to reset the password, we need to perform a post request to this endpoint here and provide the email, and then the API will send a link to this email, and the link includes a unique ID and a token within it. And in our front end, we need to configure the view or the page to extract the UID and token, and then provide password, and then perform a post request to this endpoint. And if we need to change the password, we simply need to perform a post request to this endpoint here, providing the new password and confirming the new password plus the old password. And for the Rest-Auth user, this will allow us to perform a get, which will bring or fetch the data about users, or update the data of specific user, or even perform a partial update using a batch request to a specific user. Okay, and I'm planning to cover most of this, if not all, in future tutorials. Hello everyone, so in this tutorial we're gonna create a simple app, Django app, and this app is going to be handling a response for an endpoint that we gonna program or choose. Okay, so first thing first, let's activate the virtual environment, starting the terminal, and after activating the virtual environment, let's navigate to our Django project folder, which is my API. So now what we need to do is we need to create a new Django app. So we can divide our project into apps in order to make it organized and divide the work or the functionalities of our project between the apps. So how to create a new app? It's simple. Just go Python manage.py start app, and then we choose the name of the app. For me, I'm gonna say let's name it first app. So after doing that, we notice that here we have a new folder that Django created for us. Contains all the files that we need in order to program this app and tell this app what needs to be done. Okay, so in our case now we need to, as we're working with API, to make things more neat and organized, I'm going to just create inside this folder, I'm going to create a new folder and name it API. Inside this folder I'll create two files. One file first is the URLs file, which is where the endpoints that I need to perform requests on, which is endpoints, I mean URLs, will be written there. And the second file is the view. The views is where I code or I program the app to handle the requests that's coming from that endpoint or URL. So let's start first by typing urls.py, and the second one is views.py. Okay, so inside the views.py, so there's many ways to work with views in Django Rest Framework. So according to the documentations, we have views, we have generic views, we have view sets, we have class-based views, we have function-based views. So to make things simple, as our first app, let's start with a function-based views. So in the function-based views, it's an API view, and it's pretty simple to program and to achieve our objective, as we need a view to handle a response for the request that we are getting from the URL. So let's just use the function-based views. So how are we going to do that? The function-based views, as a Python programmer, basically it uses a function, and that function is responsible for handling the responses. So let's create a function on our views.py. So the function will be like, let's name it first. First function, just to make it simple for now. And this first function is going to take an argument which is request. So, and this function will return a response. So this function will return a response. So in order to get this to work, we have to import two important things. First, we need to import something called APIView from the Django or Python decorators. That will tell this function that you are a responsible function or a view function that will be responsible for the responses that will be generated when a request comes from that URL. So let's import that from Rest Framework dot decorator decorators import APIView. Okay, and the second thing we need to import from Rest Framework is the response function, which is we use there dot response. Basically, that's it. So now we need to tell or add the decorator that we imported there to this, allocated to this function. So simply use at APIView. Okay, let me check. Yeah, that's it. So that's all we need for now. I mean, we can see more options here, but basically this is what we need. So what I think I forgot to put two parentheses here. Yeah. Okay, so that's it for the view. Okay, that's it for the view. If we go to the documentation, just want to show you something here. There's some more options that we can use. For example, inside APIView decorator, you can tell this function to be or to respond for GET request or POST request or PUT request. For example, if I put here only a GET, so this function only will react to a GET request, not to a POST request. Okay, so this defines whether this function will be executed according to what type of request we're getting from that URL that we're going to be writing in a moment. So that's it for now. Let's send some message in our response, like, you know. So the message will be sending is kind of like a dictionary key value thing. So we'll write message and the value for it will be we receive your request, for example. Okay, so that's gonna do for the view. Next step is we need to generate a URL or write a URL that's gonna be that we will use in our browser to to make a request. Okay, so this is our URLs file. So inside here the URLs will be, what we need to do is we need to write something called URL buttons. So URL buttons will contain as much URLs as we need according to what we need to do with our app or API. So let's first import URL, or let's write the URL pattern so for you guys to see. So we can start like this. It's a list URL pattern. It's a list, and inside this list we need to define which URL we need to use. So the URL will be like first, as we're using it now. Next, there's two arguments here: the URL, okay, plus the second argument will be the view that's gonna be handling the request from this URL, so which is this one that we wrote here, first function. So we need to copy this, put it here. So in order for this to work, we need to import URL. So we get this from Django, from django.conf.urls, import URL, and from .views import first function. So we imported the URL, we imported the view. Now that's all that done, we forgot to do one thing. After we start or we create any app, we need to come here to our main project folder, settings, and add the app that we started or created to the installed app. So how we do that? We just write the name of the app, which is first app, as a string. Done. That's all. So that Django can recognize that app and serve it. The next thing we need to do is we need to come to URLs here and tell our project or our main server that we added a URLs file here, and we need to tell this our project main project or our server to include all the URLs that we added here to the main URLs file. So how we do that? We just add it here. We can write path so after the localhost or 127.0.0.1 port 3000 / what comes next is what we write here. So we can write first app, okay, / this is what comes first, and then we need this to include, okay, what's in our URLs file inside the app that we created. So what we write simply include, and we navigate to that app, which is first, we write as a string, obviously, first app dot, it's inside API, API dot URLs. So that's it, and we're done here. So the next thing we need to do is we need to migrate and run the server. So let's do that. Fine. Let's make migration first because it's a new app. Run make migrations. So it's saying here the include your alconf module where we included this. It doesn't have or does not appear to have any patterns in it. If okay, maybe we misspelled something here. Maybe it needs to be URL patterns. Let's try to run again. That's it. So now let's migrate. Okay. The next step is to run the server. Let's run the server. So as the server running now, let's test or let's make a request to that URL that we created. So our URL starts with first app and after that first. So let's test that in the browser. First app. So we got this error said cannot apply Django model permission or a non-read only on a view that does not set query set. That means because you remember we set our REST framework permissions we give in our settings. We told the REST framework, we told him that, and where's the permissions, just one framework permissions. We told him that the permissions that you need to work with is a Django model permissions or non-read only. And according to that, we didn't define here in our API view what the permission that needs to be used. Okay, what permissions are we giving this view? Because you remember, as a security wise, any request that goes to the server, it needs to be handled, okay, and handled as if is it authorized, not authorized. So that's why you need to define, because we chose here, we made the restrictions that the permissions needs to be either Django model permissions or a non-read only permissions. We don't have this on our view. So what we can do, we can from REST framework decorators, we can also import of course permission classes, okay, and we can define here what permission this this request or this view needs to deal with. So for now I just need to tell this view to respond to any request that comes from through that URL. So what I need to do is use the permission classes, and inside here I need to tell what permissions I'm using. So I want to allow everyone. So for that I have to use something called allow any. I need to import this in order to use it. Okay, I need to import this in order to use it. So let's import this from Rest Framework dot permissions import allow me. Okay, so now any request that gets through this URL will be handled. So let's save this and try it. If we go now here and we refresh this page, as you see now it worked and we got this we receive your request which we wrote in our APIView use.py file. So that's it for this tutorial. Next tutorial we're gonna just do some more work in our view and see what else can we do or what cool things we can do with it. Thank you guys for your time, and until next tutorial. Hello everyone. Today we're going to talk about how can we send parameters through our endpoints or URL that we created for our application, Django application, and how we can extract those parameters in our view.py, the function-based view. So first thing first, let's start a terminal and run our server. First we need to activate our virtual environment. Okay, and then navigate to our API folder, and then run the server. Okay, so after we run the server, let's go to the browser and just make a request to our URL or endpoints, and as expected we get a response back, says that we received your request, which we programmed here. Okay, what if I want to send some parameters within this URL? So let's try to type something after the first, anything. Just hit enter. You see, our API will ignore all those characters because for our API that doesn't mean anything. Okay, so how we make this meaningful? It's very simple. We just need to add a question mark here, and that would tell our API that whatever characters after this question mark is part of the dictionary. The dictionary includes the key value parameters, which means you have a key and you have a value for that key. It could have like one key value, 2, 3 or more. Okay, so how are we gonna extract whatever comes after all the parameters that we just included here? Okay, it's pretty simple. If we go back to our view, you see that we used request here as an argument in our function-based view. So we can use this request to extract the parameters. How? Let's just simply first print those parameters. Okay, let's go print request dot query underscore params. Okay, so let's try this for now. We save, we wait for the server to rerun, and then we go to the browser. If we do refresh here to create another request and we check our our print field here or terminal, we can see that we have a query dictionary, includes a key, but there is no value. Okay, but at least we managed to get this, all these characters in our API or backend. So how are we going to put a value here for these characters? Oh, let's use some meaningful characters here. Let's say key, or let's say ID, for example. Sorry. After that, we put equal, and we write, for example, 1 2 3 4 3 4, and we hit enter. Now, if we go back and look here, we see that we managed to get or to extract a dictionary with an ID key and a value. Okay, how to get this value from this dictionary? Well, it's simple. If you just go here, let's do another print statement, and what we need to print is request dot query params, and we tell the which value. Okay, we need to print the value for which key. Okay, we just write here or type key. Okay, and then let's save it and try if we see if we can get that key from the dictionary. So if we run this back again, it's giving an error saying that key is not. Oh yeah, because it's not key. Okay, that's why I wanted to write key, but then I changed it to ID. So that's wrong. There's no key in the parameters. There's ID. Okay, so if we save this and we come back here and we do refresh, okay, this was successful. If we go back here and check, do you see this number? This is the value for the ID key. So we managed to extract first the parameters as a dictionary and then the values from the exact dictionary. Okay, what if we need to send more than one key value in the dictionary? It's simple. We would need to create a separator. Okay, so if we need to create a separator between, if we need to add more than one variable or more than one key value, we need to just separate them. Okay, and then write another key, which is, for example, key equal another value, which could be, for example, km1234. Okay, let's hit enter, and if we go back here, if you look here, you see that our dictionary now has an ID with the value and also has a key with the value. Okay, and what if we want to print the value for the key? Okay, we change this to key, and that's it. If we go now and do another request, and come back to our server and check, we have the value for the first key, the value for another key. That's very handy when it comes to, for example, if you want to send some information with your request to your API, like if you want to send some ID and in your API or server, you want to use that ID to filter some data from your database. And we will see that when we use the class-based functions or view sets. So we can send some values within our endpoint or URL, and then we can use it there in our server to filter some data from our database, fetch some data, and send it back. Okay, Obviously, what if I need to send back those IDs, for example, or let's say I want to send a number here, okay, and do some operation in it, let's say 12, and send it back, okay. We need to take out this from here because we removed it. Okay, let's wait for the server to run back. Okay, that's it. Also, sending parameters through or within our API endpoint or URL is useful. For example, if we want to send some variables or some values and do some operation in it on our API or backend or our server, and then send the result back, that will be handy. Let's do a simple operation. For example, let's give our ID. Let's send a value of, for example, let's send number 12 to the API and ask our API to do some operation on it and send the result back. Okay, so let's send something called, for example, num, the number. Let's go to our API and update the key here to num, save, and now let's test. Okay, if I send this request, I can see now the number 12 is printed here. So let's ask our server or API to multiply this number by 2 and then send it back. How we can do that? Simply let's assign this value here to a variable. Copy this. Let's say number equal this value, and then let's say new number equal number multiplied by 2. How we send it back to the browser, or how we add it to the response? As you see, the response is just a dictionary key value. So let's add another key value here. So the key will be result, for example. Okay, and the result is the new number. Okay, let's try this. Let's save it, wait for the server to run, and then just refresh here to send another request. So why we supposed to multiply it by 2, but we got the result, which is okay, but the result is not correct. So what happened? So what happened is that this value that we got from here is not an integer, it's a string. So when we asked our API to multiply it by 2, it just added another string or another 12 and put it next to that 12, and that's why we got this 12 here. So what if we want to make it do the real work for us and multiply the numbers? It's easy. We just put int, and we include that inside the int function. So now this will be converted to an integer, and we will be able to get the right value. Okay, let's save, and then go back to our browser and refresh, and here we go, we got the 24. Okay, so there's many ways that we can use this trick, or this way of sending variables through our endpoint or alt or server API, do some operation in it, send it back, and so on. So that's it for this tutorial, guys. Thank you so much for your time. Until the next one. Hello everybody, today we're going to talk about permissions and authentications. So we know that REST Framework provides us with many methods of authentications and permissions. And what we're going to do now, we're going to speak about what's the best to use and how to use it. And we will do that using decorators, because now we are using a function-based view, as you remember in the last app we created. So guys, let's check the documentation and see what options we have. On the documentations, if you go to Django Rest Framework Authentications, we can see that first thing first, REST Framework provides us with two default authentication methods. First one is basic authentication, second one is session authentication. So basic authentication is basically when you provide a username, password to the server or where you're hosting your API, and then the server will check if the passwords or the credentials, the password and username are correct. Then it will give a response telling that that this request is authorized, and will give us like the username, for example. Session authentication is a bit different, because session authentication actually relies on something called session. And session, what is session? Session is when the server creates some kind of data to store some information about the user. For example, after first login from the user, the server will create kind of let's say dictionary, or in JSON format, kind of data about the user, like an ID. It will give the user an ID. It will give maybe it will store some metadata about the user, like if the user is admin or a normal user. Maybe it will store what pages this user visited, or from which page the user made the request. It's just kind of tracking users are in the website. So what happens is the server will send this, after creating this session data, will send it to the browser, and it will get saved there, maybe in the local storage, maybe in the memory or something like that. So if the user comes back, the user doesn't need to log in again, because the session data is there, so the user can carry on using, because this session data has an ID that will be sent back to the server to authenticate, so or to tell the server that this is the same user that was using this before, and something like that. So, but we're not going to be using that. Actually what we're going to be using now is token authentication. Token authentication is a secure authentication, and is very reliable and secure, and highly recommended. And actually most of the APIs use token authentication, especially in the applications where you use, for example, a mobile app, or a desktop or web app, and you need to send requests to your server API. So what we need to use token authentication. To use token authentication, we need two things. First, we need to add REST Framework Auth token to our installed app, which we know. Where is it? If you go to our settings, the main project, here all our apps added here. So to use token authentication, we need to add the app here. So we can add it here. For example, maybe we add it here before. It doesn't matter, but I just keep things, you know, a bit organized. So Rest Framework Auth token must be installed there. And the second thing, as you see in the documentation, we need to define in our, well, maybe it's not here. So if we go here, where the Rest Framework is, you see here, default authentication classes. We have basic authentication, session authentication. I'm gonna comment out those because we're not going to be using them, and I'm going to be using the token authentication. So this is what I'm going to be putting here. It must be a string. It's a list. It's a list of strings. So it needs to be token authentication. Okay, to make sure we're spelling it right, we need to come here. Yeah, that's it. Token authentication. So after we added that, you see, now we added that to the setting. We told our REST framework that default authentication classes must be a token authentication, and we installed the REST framework auth token, installed app. Now, after that, we need to tell the REST framework or the API or our server what permissions to use. Because if we chose to use token authentication, we need to tell the server or the API that the permission that we need to use is authenticated. So if we go back to the documentation and we go to permissions, so let's see what permissions REST framework can provide. Okay, so first thing first, if you look here, you see here, this is a default permission classes. Okay, it says if we are using a token authentication, so we need to add this to the permissions. It says is authenticated. Okay, don't worry about this now. So is authenticated is when you use token authentication class or authentication method, okay, that requires token. Okay, so what about allow any? If you remember, we used allow any in the last tutorial, and why we used it is because we needed to make things simple and allow all the requests to that API through that endpoint or URL. What else we have here? We have as admin user. So what that means? That means is if the user is already a user, is not enough to do that request. It needs to be a registered user plus as an admin user. Okay, is authenticated or read only. Okay, what that means? That means the user that's making a request to our API, if it's authenticated user or authorized user, then it will have access to all the functionality like put, post, and other get, all of them. But if it's not authenticated, that means we can't give those unsafe permissions where the person who's doing the request can modify our database or can add, delete. We can't do that. We give them a read-only permission, so we give them access to get, or option or head, also those simple safe requests. Okay, a Django model permissions or a Django model permissions or none read only. Those are included in the Django framework, which we can access them from within an admin panel and choose them. I will show you that when we run the server. Okay, so we're not going to talk about custom permissions or object permissions at the moment. So let's give it a shot and then let's add those authentications. So we need to add this, as we said, to our permission classes. Okay, we need to comment out this because we're not going to be using it now. String as usual, and okay, let's save this. So after I did that, let's take a look to the view. You see here in our view, we said we can, when we're using a function-based view, you can use decorator to define which permissions we need to use. Okay, so I'm gonna remove this now, or comment out this. Okay, after we did the configuration in our settings for .py file, now any request we need to make to our API, it needs to be authenticated. Okay, in other words, we need to include a token on or in our request header. If you check the data, the documentation here, I want to show you when we're talking about authentication, and if we check the token authentication, see, token authentication is appropriate for client-server setups. Okay, such as we said, or mobile clients. And I'm just looking where to show you what they recommend for that, but it doesn't seem to be here. Okay, anyway, I'll show you now when we do it. So as I said, any request we do to our server, after we activate the token authentication and is authenticated, it needs to include token. Where we get the token from, you know that because the last tutorial we spoke about, or we showed you how we got the token after we added Django Rest-Auth to our project. So let's run the server and see that in action. Okay, so first let's activate our virtual environment. /env scripts activate. After that, let's navigate to our API project, and now we can run the server. Let me get rid of this. So it's giving me an error, says application labels are unique, duplicate auth token. So maybe auth token was there and I added it again. Let's see. Yeah, it's already there, so I don't have to add it again. Okay. We save this. Okay, here we go. We have our server running. Let's go to the website and try to do a request to our first app, which is, let me get the URL right. So it starts with first app, then first. And we'll see what request we will get. So when I send a request to this URL, what I got from the server or from the API, authentication credential were not provided. What that means? That means I told the server, or I told the API to ask for authentication token. Okay, so I now made a request without providing that, so that's why the server gave me that response. So in order to provide that and see how it was, I'm going to use a very handy application called Postman. Postman is an application that firstly was made to test APIs. Okay, that's what the purpose of it, and it's very handy, and it's very helpful when it comes to testing APIs, sending requests, adding credentials or headers or all of that. So here, let's provide the URL. We can copy the URL from here. Okay, and choose what request we need. We need a GET request. Okay, if we go to headers, what we need to add here, we need to add a key value called authentication, and then we need to add this is the key authentication, which we need to use to authenticate. Type of authentication is token authentication, so we need to add the keyword token space, then we put the token for the user. Where we can get the token for the user, we can get it from our admin. If we go to admin, so it's my API, password, okay, let's try again. I'm not sure if I forgot the password. Maybe I did. No, I didn't. Okay, so as we know, we spoke about first, we have tokens here. Tokens is a unique keys that gets generated for each user that gets registered to the database. So for this user, this is the token that we need to use. Okay, so we copy this token and we come to the Postman application. So before we do that, let's try to send a GET request to this URL without adding a token. Okay, if we sending request, what we're getting here, invalid token header, no credential provided. Okay, so no credential provided, we get nothing. Okay, let's provide a credential. Let's provide a token. So if we add the token here, so now we are telling the server when we send this request that the person who's sending this request is a registered user. And now we can try again and see. You see, we got the request. So the server recognized that this user is authenticated, is a registered user, and sent us a request as we coded here in our view. Okay, so basically that's it. Okay, basically that's it. So this will be applied to all the views that we will be writing or coding, because basically it's in our application settings. Okay, it's here. Okay, there's two ways to do that. Either doing it here, okay, or doing it here in our views. So maybe this is the general rule that you need to, or authentication class that you need to associate to all the users in your server. But if you need a specific authentication for a specific view in your API or specific database, you can always use decorators to modify that. For example, if I uncomment this, okay, now the server knows, or we told the server that every request must be authenticated, as you said. But I came here to our view and I told now my server or my API that for this specific view, I need all the users to be able to access. So now, if I go and try to do a request, and if I need to remove the token now. Sorry. I removed the token and I'll send a request. I'll still get the request because this has a high priority. So our server or API ignored, for this particular view, ignored what we wrote here in our settings and listened only to what we wrote here. Okay, so we made a specific rules for each view we have. Okay, and if we do it the other way around, I mean, if we choose to do it this way, if I told let's say this will be allow any, okay, allow any, and if I save it, that means all the requests to our server or API will be accepted. Okay, no authentication is needed. Okay, if I come here to views and comment this out and save, if I come here, okay, I don't provide any authorization or any token and I send a request, I will get a response from the server because I told the server all the requests are allowed. Okay, even though I said that on the settings, if I come here and import the permission that says is authenticated and I use this here, now if we test, let's go to the postman and I send a request. Let's say authentication credentials were not provided, which means I need to provide a token here. And if I go here and provide a token, okay, and let's go get the token. And send, I get the request. So that's it, guys. For this tutorial, we wanted to just show you how it works, or how you can add authentications, add permissions, and how can you play with them, or can make specific authentication for your view, regardless what you wrote in your settings. Which means if you have multiple views, multiple applications, you can tell each view or you can associate a different permission class to each view you want, depends on what you want to do with it. Okay, so that's it, guys, for this tutorial, and until the next one, thank you.
Hello everyone, in this tutorial we'll be talking about
a new way of authenticating our users in our API. And normally we used to use something called token authentication. Okay, and basically token authentication was a key that the API generates when a user registers in our API or database. Okay, and basically it is a key that's linked to the user's account, and whenever this user needs to access some data from the API or post or request, the user needs to use this token key. Okay, and this is not the only way to authenticate a user or a request to our API. The other way that we need to talk about in this tutorial is the JWT, which is JSON Web Token. And what's special about it, or why we would need to use JWT? Basically, if we need to reduce the database lookups in our API, JWT will be our first option, because JWT tokens, which are two tokens, an access token and a fresh token, they don't get stored in our database. Basically, when we request a token, the token gets generated and then we can use it to authenticate our user in our API. And I think it's pretty good way of authenticating users, especially knowing that it's not getting stored in the database, which makes it less vulnerable. Okay, there is a downside of that as well, which is I'm gonna mention at the end of this tutorial. But for now, let's dive deep and let's see how can we implement JWT or JSON Web Token on our REST Framework API. To do that, we're gonna implement, or we're gonna use something called JWT symbol, or what's called symbol JWT. And I'll leave a link in the description for the documentation. And to get started, we need just to pip install it. So first, let's go to our project and let's open a new terminal. And first thing first, we need to activate our virtual environment. Okay, so it's in the parent folder. Let's activate it. Scripts activate, and then let's navigate to our project folder, and then here we can install the symbol JWT. Let's copy this, paste it here, and that's it, it's installed. So now let's go back to the documentation and see how can we implement simple JWT in our project. So here it says in our REST framework authentication settings, we need to add the JWT authentication. So I'm going to copy this, and inside here previously we used the token authentication, so I'm going to comment this out and then add the REST framework symbol JWT authentication, JWT authentication. Okay, one other thing I need to do here, you remember we left this permissions as allow any because we needed to perform post and get request easily without having to add a token to the header. So now we need to change this to is authenticated to be able to test the JWT authentication. Let's save that, and then now we need to add the endpoint of the API token or the JWT token to our URL file. And to do that, simply we need to import two classes here, the Rest Framework symbol JWT views. Let's copy that and go to our URLs, and then we'll add the two endpoints, which are these here. I want to add them after the Rest-Auth registration here. Okay, let's delete this. And now, as you see, the first endpoint, it's API token, which is used to generate the token for the user. The second one used to refresh the token, because this token is kind of temporary, or it has a short life time, which means it gets expired. So, and it's a very good thing about it, and we might need to generate another one to grant an access for the user to our API. So we'll use the token refresh, and let's save this. And now I think that's it. Let's take a look at on the documentation. Yeah, that's all we need for now. And then now we can run our server. Run server. And what we need to do is we need to go and use our posts app, which we created in previous tutorials, and then we will use it to test the authentication. So I'll use Postman to demonstrate that process. And first thing first, we need to get the token or the JWT access token, because now if we just go to posts and perform a GET request, it'll say authentication credential were not provided. And how are we going to fix this? We need to authenticate the user. To do that, we need to perform a post request, because API token accepts post requests. So let's perform that. And we paste it here. And if we perform a post request, it'll ask us for username and password. And as you remember, when we used the token authentication, we sent a request to the login endpoint, and we provided username and password, and we got the token back from our database. In the JWT authentication, we provide the username, password, and we perform a request to the API token, and the two tokens, which is the access token and the refresh token, gets generated. They are not stored in the database, they just get generated. And to achieve that, let's go to the body and then add username, which is my API, and password, And now that we provided the username and password, we will perform the request again, the post request. And as you see here, we got back a refresh and access tokens. So in order to perform requests to the API, we need to use the access token. So where to implement this? We need to add it to our to the header of each request. So let's copy this. And now let me just add the endpoint for the posts. Okay, let's go to get request. And now it's telling me authentication credentials were not provided. So if I go to the header, and normally with token authentication, we add the authentication token, and then between two quotes here, we add the token key. Now, this type of token is called, or the JW token is a barrier token. Okay, so we need to add here barrier, and then space, and then paste the token. Okay, and now we can perform the GET request. And as you see here, we got authenticated and we got all our data back. So basically, if you're gonna check this token, it's not stored in our database. And that's very important if you wanna save or reduce the amount of lookups into your database. The downside for using JWT or JSON Web Token is that it can't be revoked. And it can't be revoked, which means once the user once the user gets access or gets the access token, you can't revoke this access token. You can't just prevent this user from accessing your API. And that's when refresh token comes in place, where you can always generate new tokens for the user, so the token gets expired or the access token gets expired. And to demonstrate that, if let's say our access token is expired, and now let's go to request the posts, and then using get request, and we have this the same access token that we used just now, and then let's perform a get request. And you see here, as you see, the response is saying here it's a token class, and it's saying the type of the token, it's an access token, but it's telling me token is invalid or expired. And in this case, we need to refresh the token or generate another access token using the API token refresh endpoint. Okay, and in order to do that, we need to add the refresh key that we received when we requested the JWT tokens. And because I didn't save that, so I need to request another access tokens like this token, and we'll do a post request, and then we don't need this, and let's add the username and password just by checking this here, and then perform the API token. And as you see here, this refresh token, I need to use it in order to refresh the access token or generate another one. And how to do that, I need just to copy this and add it to the body format. Okay, so I'll add here refresh key, and I paste the refresh key here. So now if I want to generate another access token because this one gets expired, I just need to perform a post request to the API token refresh, and I only need to include the refresh key value here, and let's do it. And as you see now, I got back a new access token, and if you compare with this one, let's compare the end, and you see this one ends with WBGE, this one ends with UMS0. And now in order to perform any new request, I need to use this one, because if I use this one, the old one, to get the posts, for example, let's get it and try. It tells me that access token is expired, so I need to use the new one. It's pasted here, and then perform another GET request, and as you see, I got all the posts that I previously stored. So that's it, guys, for this tutorial. I hope it was useful, you learned something new, and if you have any question, please leave it in the comment below, and until the next one. Hello everyone, in this tutorial we will use throttling to determine if a request to our API should be authorized or not, which sounds like permissions, but using throttling will allow us to control the rate of requests that a client can make to our API. And there are many use cases for that, and one of them, let's say you have an API where you providing a service or some information like a weather app, and you want to limit the amount of requests a user can make per day or per hour or even per minute, and you want to give a different restrictions between subscribed users or unsubscribed users, or some paid plans or unpaid plans or free plans. So that all can be achieved using throttling, and it's pretty easy to use, guys. So to get started or to demonstrate the use of throttling, we're going to use one of our applications that we created previously in this tutorial. There's no need to create another app. So one of the applications that we created previously was a cars app, where it holds some information about specific car. So if I go ahead and run the server, and please make sure your virtual environment is running. So I'm going to just run the server now and wait for the server to run. And after that, if I go to the Postman, and as you remember, guys, whoever watched that video about the cars app, this is the endpoint that we use to, or we configured to access the API. So if I perform a GET request, I'll get the information that's stored in our database or API database. So I can perform as many requests as I want. Okay, there's no limit for the amount of requests I can perform. So what if I want to throttle that, or want to control the amount of requests that a user, which is, for example, now I'm unsigned user or unauthenticated user, so I need to create a limit for unauthenticated users, like maybe they can perform just 5 requests per hour. Okay, So in order to achieve that, I need to add some settings to our project settings.py or API settings.py. So if I go back to the code, and inside Rest Framework dictionary, I need to add some configurations here for the throttling. Okay, so we have different type of throttling. So first we need to add what's called the default throttle classes inside the Rest Framework dictionary. So I'm gonna paste that. So what is throttle classes exactly? These are the classes that configure the type of throttling that we're using. For example, first one is a non-rate throttle, which is mainly for unauthenticated users, and the second one, which is the user rate throttle, is for authenticated users. The second thing we need to add is the default throttle rates, which determine the amount of requests per specific period of time. So for example, for a non-type, which is unauthenticated users, I'm allowing here 2 requests per day, and for an authenticated user I'm allowing 4 requests per day. Okay, so let's go ahead and test that and see how throttling is controlling the amount of requests. But before that, I want to disable the caches here, and just comment it out, and I'll tell you why in a minute. So let's save this and then run the server and wait for the server to run, and then we'll go to the Postman and perform a GET request to the API using the cars app endpoint. So I'm going to perform a GET request first, and as you see, I got back a response, and we are performing this GET request as unauthenticated users. So I'm not providing a token authentication yet, it's not ticked. So I'm going to perform another GET request, and as you see, a GET response back. And if I perform the third GET request, I'll get back request was throttled. Okay, so the API saw that I'm trying to perform a third GET request to the API and blocked that. So if we now perform a request as authorized or authenticated user, let's try it. So I'm going to perform first request, a second request, a third request, a fourth request, and then the fifth request will be throttled. And as you see, guys, I was able to control the amount of requests that allowed or authorized in our API. So that's great, but it's a quite general. And what if we want to apply throttling to specific parts of our API, like different apps or different applications? Is that possible? Well, yes, it's possible. And for that, we're going to use scoped rate throttle. So if we go here to default throttle classes, let's remove the previous two and add the scoped rate throttle. And after we add this, we need to specify some keys or the names of the scope that we need to use. So I'm going to use one for the cars app, and the other one I'm going to use it for the first app. So to do that, I'm just going to add here cars app, and underneath I'm going to add first app, and I'm going to leave the rates as they are, and then I'm going to save the settings. And after that, I need to go to the cars app view, and inside the cars API view I need to define the throttle scope. So I'm going to add throttle scope equals, and then I'm going to put here the name of the scope, which is cars app. And then I'm going to do the same thing. Let me save this and do the same thing for the first app inside the views. Inside the car specs view set, I'm going to add the throttle scope, and I'm going to give it the name first app, and save it. So now we need to test this by performing requests to the API using the cars app endpoint, which is this one here, and see when the throttle will be applied. And then after that we will perform a GET request for the first app, which is this endpoint here, and see when the throttle gets applied. So according to the settings that we made here, we have 2 requests per day for the cars app, 4 for the first app. So let's see if that's working. So I'm going to perform here for the cars app 2 requests. So I'm going to perform the first one. I got the data back, and the second one, and the response is still here, and then the third one should be throttled, and as you see, it's throttled. So if I go to the first app with the car specs, I'll perform a GET request. So first one was successful, the second one was successful, the third one, and the fourth one, and now the fifth one should be throttled. So as you see, the request was throttled. So I was able to control or throttle each application separately, which is great. One more and very important thing I need to show you guys. So if we come here and we close the server and then rerun the server again, and then go to the Postman and perform a request to the API, I'll see now I get a response, and if I perform another request I get a response. It looks like that the throttling has been resetted. Okay, and same thing if I go to the first app endpoint and perform request, I get a response. And that means if my application or my server restarts for some reason, all the throttling configurations or settings get resetted, and that's bad. The solution for that, which is recommended by the Django Rest Framework documentation, is to use caching, and that's what I commented out here, the cache configurations or settings. So there are many ways of using caching, and it's all in the Django documentations. You get like memory caching, file system caching, you get database caching, etc. So I'll leave a link in the description for the Django documentations about caching, and for the purpose of this tutorial I used the file-based caching from Django, and for the location I specified the location of my project folder. And after adding this settings or caching, we will see, guys, that even if I restart the server, Django will still remember the throttling data or the rate of requests to our API. So I'm going to save this, and then I'm going to close the server and rerun it. And now I'm going to go to the Postman, and here I want to perform first GET request and second GET request, and the third GET request should be throttled, which is what happened. Same thing goes for the first app. So I'm going to perform here 4 GET requests, and now it's throttled. Now I'm going to go to the server, close it, and then run it again, and then I will try to perform a GET request to the API. So if I perform a GET request here, I'll see it's still getting throttled, which means that Django remembered that from this IP address, which I forgot to tell you guys. Throttling uses either the IP address of the client, if the client is unauthenticated, or the ID of the client, if the client is authenticated, to create kind of a reference key to this client to know, or to control the amount of requests that this client has made to the API. So as you see now, after adding the cache, Django remembered that this client already requested 4 requests to the first app, so it can't perform any more requests, and that's very important in production. And I highly recommend, guys, that you check the documentations for the Django Rest Framework throttling, which is, I'm going to leave a link in the description for it, and the Django cache documentation. I'm also going to leave a link in the description for that. Hello everybody, so today we're going to talk about what we need to make it possible for our front end, like a web app or mobile application, to communicate with our model that we created, send and receive data, and do other stuff. Basically we need something called serializers and views. You already know what views are because we created a view and we managed to do some functionality with it. But to do more and be more advanced and be able to communicate with our models and store data, send and receive, we need to work with something called serializer. Okay, what is a serializer? Basically, a serializer is a kind of converter, okay, that convert the complex type of data like models, query sets, into a normal or native Python data that can be rendered as JSON or XML, which as developer we understand, our front end can understand. So if our front end needs to work with like JSON, okay, we need to work with JSON data because we can understand the data in it. Okay, we don't need that complex type of data. So serializer will do all the hard work behind the scene to make our front end understand the back end, to make it easy for our data, okay, to go back and forth, through our API, okay, to be stored, to be converted, okay, and much more. How to implement that? Well, it's pretty easy because we need to work with something called model serializer, okay, because we already created a model, okay, which presented our data, okay. So the easiest way is to choose a model serializer. Why we need to choose model serializer? Because a model serializer will basically deal with our model that we already created. It will serialize all the data that well, according to the fields that we already added in our model, so there's no much work to do. Okay, so it's easy to achieve because all we need to do in our serializer or model serializer is to tell it which model that we need to serialize data from and the fields that we need our serializer to handle. Okay, and the serializer will do all that. We will like go look to the model, check the fields, any operation that we need to do to the database through that model, like sending data, receiving data. Okay, all the get, put, post will go through the serializer, and the serializer already knows the model and the fields that inside that needs to deal with, so that will be easy to achieve and we'll get our work done. So how to implement that? So let's go here to our API where we added URLs and views. We need to add another file here, a Python file, and call it Serializer. Inside this serializer we can add our serializer code. So how we do that? First, let's import the serializer from Rest Framework. Okay, so from Rest Framework, import serializers. Okay, then we need to import the model that we need to serialize data from. So this is the model file here, so we need to import car specs. Okay, so let's do that from first app dot models. Well, I did this because it's not in the same directory, so I had to go outside of this folder and then get back into to get the models file. Import car specs. So now let's build our serializer. It's a class that we need to choose a name for. Let's name it car specs serializer. Okay, and what we need to inherit is a model serializer, as we said. So it's from serializers dot model serializer. Okay, what data we need to add here, or metadata that we need to add here? We need to add the model, okay, that we need our serializer to deal with. And so first let's add the model equal car specs, and we need to tell the serializer which field it needs to handle from this model. So we write fields equal, it's a list of string that needs to include all the fields, or basically the fields that we need to deal with. Okay, if we go to the model, what fields do we have? Car brand, car model, production year, car body, engine type. Okay, so let's write them. Car brand, car model, production year, and what else? Body type, citation, and engine type. think that's it. Let's double check again. Engine type, car type, not body type, car body. Okay. So that's it, guys. We wrote our class, Serializer class. We told the Serializer class that you need to deal with this model, the car specs, and we gave it the fields that needs to be serialized. Okay. So thanks, guys, for your time, and until the next tutorial. Hello everyone, in this tutorial we will see how can we add extra fields to our API response using the serializer in order to enhance the response and provide more data on the go without the need to store that data. And to demonstrate that, I created a new app. I called it Racing. It's a simple app, and inside the models.py I create a model that represents the driver, and this model has 3 fields: the driver name, the car brand that the driver is driving, and the round finishing time. And this will represent for example, Formula 1 racing, where the car needs to finish multiple rounds at a certain time. So this model will represent that, and I created a serializer also here for that model that will serialize the data from the model, plus a model view set in order to process the query from the database, and plus a urls.py to give me an endpoint for the requests that I need to perform. And as you notice here, I didn't put the views URLs serializer in an API folder because I've been receiving questions that why we are putting these files, the serializers, URLs, and views.py files inside an API folder. Does it have to be this way? So the answer is no, it doesn't have to be inside an API folder. It's just a way of organizing your files. You can put it in the root directory of your application. It doesn't matter. So let's run our server and then add some data and see how can we add an extra field to our response. So first thing first, make sure your virtual environment is running in the terminal, and then run the migrations. So after you create any application, you need to run the migrations. So first you make migrations, and then it will detect if you have a new data. I already did the migration, so that's why it's not detecting anything. And then you run migrate, and then after that we run the server. Okay, so no migrations here because I already did the migration. Now we just run the server, so python manage.py run server, and then after we run the server we'll go to the admin panel, and then there we will just add some data to demonstrate the whole process. So if we go here to drivers, and then let's add some data. So let's say the first driver name is Joe and his car is Mercedes, and then he finished the first round or the round in let's say 15 minutes, and then we save it, and then we add another driver, let's say Mark, and then we his car is BMW and he finished the round is like in 14 minutes, let's say. these are just examples, guys. And then we add another driver. Let's name, for example, Steve, and his car is McLaren, and he finished in 10 minutes, for example. One more, let's add one more. Oh no, let's see if that's enough. Okay, so if we open the Postman and perform a GET request to the URL or the endpoint that represents our application, we should get our data from the database. And you see here I've got the 3 drivers with each one's finishing time. Okay, we are representing here, for example, 1 round, okay, in the race. So this is a normal response from the database, telling us the information about each driver. Okay, what if I want to know, for example, or add to each object of these the best time, okay, or the best record that a driver did, not specifically Joe, for example. You see here, for example, Steve did the best record because he finished the round on 10 minutes only, and I want to show that here with the object, or the Joe's object, for example, or Mark's object, that Joe's time was 15 minutes, but this wasn't the best record because the best record was achieved by Steve and was 10 minutes. So I want to do that or achieve that by adding an extra field to the response inside a serializer. So if we go to the serializer.py file, in order to add an extra field here, first I need to declare a variable as a serializer method field, and I will name it best record, for example, best record equal, and this will be a serializer method field. So I'll just say serializers dot serializer method field, and inside here I want to specify the name of the method that I want to create, and it will be a private method. So I'll start with underscore, and then let's name it get best record, for example. And down or below this I need to define this method, and then this will take self as an argument, plus it will take the driver object, and this object is the object that's coming from the view, okay, or the driver object. And inside this method, because I'm getting the driver object here, so I can extract the finishing, as we see here, the model. I can extract the round finishing time from it simply by typing round finishing time equal get attribute, and inside here I'll specify the object, which is the driver object, and then the field that I want to get the value for. So it's the rounding or round finishing time. So by doing that, I'll get the round finishing time for each driver. Okay, and now what I'm going to do, I'm going to compare this finishing time to a best, let's say best record or best time and then if it's below the best time, I'm going to update the best time. If it's not, I'm just going to return the best time. Okay, so I'm going to declare here, just to make it simple to serve the purpose of this tutorial, I'm going to just declare a variable, call it best time, and I'm going to set it to 30 minutes, for example. And then inside here, I'm going to say if the round finishing time is existed and the round finishing time is smaller than best time, then what I'm going to do is I'm going to return, okay, I'm going to update first the best time. So let me just bring it here. So in order to use the global variable inside this method, I'm going to say global best time, and here if the round finishing time is smaller than the best time, I'm going to update the best time. So best time equal round finishing time, and then I'll return the best time. Else I'm just going to return the best time, which is the previous value of the best time. Okay, so what this will do is we'll check each finishing time for each driver compared to the best time that was achieved in that round, and then give me back the best time. And this will allow me to add best record as an extra field to my serializer. So I can simply just say best record and add it here. Now let's save that and wait for the server to rerun. And now if we go to Postman and then perform the GET request, I can see here that each object came back with an extra field, which is the best record. So this first one was Joe. Okay, Joe finished the round in 15 minutes. So what this function or method in the serializer did is compared this 15 minute to the 30 minutes, and then found that 15 minutes is smaller, so it returned best record 15 minutes. The other driver came and then achieved or finished the round in 14 minutes, and then the method did the same and updated the best record. And the same thing happened to Steve. And let's say that another driver came and completed the round in for example 13 minutes. So let me go and add this driver. To do it quick, I just want to do it in the admin panel. So I'm going to come here and add another driver. Let's for example say Sam, and he's driving a Ferrari, and then he completed the round in 30 minutes. Let's save it. So if I go here and perform another GET request, I'll see that even though Sam completed the round in 13 minutes, I got here the best record 10 minutes. So it's showing me that Sam didn't beat the best record, which is 10 minutes. So as you see guys, we managed to add an extra field, do some calculations and provide more data without even the need to store this best record. Okay, and this is very handy in lots of applications, and for the purpose of the video I just made it simple just for you guys to see how can we add that. Obviously here you can add more fields by just declaring another serializer method field, and then adding another method, and then returning another value, and then just add the name of the field here. Plus inside, for example, inside the serializer, because you're receiving the object from the view, you can use any field of this object, for example, to perform another query and then return a value and add it as a field to the serializer. And this value here is just, I made it, I declared it as a global variable. It could be, or it should be, coming from the database as a best time, but just for, or to make things simple, I just kept it this way. Obviously it's not the best practice, but hopefully guys you learned something new from this video. Hopefully guys you'll make use of this in your applications in case you need it. And that's it guys for this tutorial. I hope it was useful, and until the next one. Hello everyone, today we're gonna implement or use a new class view to and take advantage of the serializer functionality to be able to communicate with our model, car specs model, which we created, and send and receive data and store data in it. So let's get started. So let's go first to our view.py file, and what we need to use is something that REST framework provides, which is view set classes. Okay, so it's view set, it's a view, or it's a kind of it's a class that gives us many ways of dealing with our requests. Okay, storing data or communicating with our models, retrieving data, creating data. Okay, all that functionality can be provided inside the view set. So to use the view set, first we need to import, okay, view set from our REST framework. So from REST framework, import view sets. Okay, view sets is a class. Okay, so let's create that class and give it a name. Class, let's name it car specs. Okay, view set, and this class needs to inherit from view sets dot model view. Okay, because we need to deal with model, which is our table for car specs. So we need to inherit from model view sets, which gives us functionalities for getting queries, data from our model, filtering the data, storing data on our model, and all that. First thing first, in our class of class view, we need to tell this class view which serializer it needs to use. Okay, and as you remember from the last tutorial, we created a car spec serializer. Okay, and this car spec serializer needs to be used in our view. Okay, so basically here we need to tell this view to use that class or that serializer by just typing serializer class equal, well, car spec serializer is not imported, so let's import it. from serializer.py import car specs serializer. Okay, so just add it here. So now our viewSet class knows which serializer it needs to use. Okay, after that, what we need to say, we need to tell the view, we need to write a function and tell this view where to go and pick up data, or where to go and store data. So how we do that? We write a function called getQuerySet, and inside this function, okay, we need to get all the objects from our model. So we need to do that, we need to first import our model. So from first app dot models import car specs. Okay, so here we need to set up a variable. Okay, let's name it car specs, and equal to the car specs model dot objects dot all. And by saying that, or by writing that, we're telling that our view to get all the objects from car specs model. That means all the data from it. Okay, and then we simply return the data, which is car specs. Okay, so we got the data, we returned the data. So now what we need to do, we need to go and create an endpoint, a URL that whenever we do a GET request on it, it will come to this view, it will execute this function, go get the data from the model and send it back to us. Okay, let's save this and let's go to our URL.py. Okay, here there is some changes that we need to do because we're working with viewSet. Okay, we need to use something called routers. So what routers do? A router in this, or router in this, in URLs will basically deal with our endpoints or URLs. So we don't have to write a URL or wiring all the type of things, like writing defining that this is a URL, okay, and writing well, we'll still need to write the name for it, but we don't need to specify it as a URL. Okay, so the router will do that for us, and the router will communicate with the view, okay, viewSet, and identify what kind of request we are doing through this URL. I mean, if you're doing GET, POST your request or any other type of request, and we'll deal with the view. Okay, so to use the router, basically it makes everything run smoothly. Okay, so let's import the router from Rest Framework dot routers import I think it's a default router. Yeah, it's default router. Okay, so how to use it? We need to create an object called router, or any name you you choose equal default router, and after that we need to register an endpoint in it. Instead of doing this, we need just to register inside this router. So we go router dot register, we open parentheses, and we write what's the endpoint will be car specs. This will use it in our URL, comma, and we need to define here which view the router will go and use. Okay, so to do that we need to import from views, import car specs view set. Okay, then we're gonna use it inside router. Okay, so, and after that we need to include this router or router.urls in our patterns. Okay, how we do that? Okay, we can come here. Okay, there's many ways to do it. I'll show you what's in the documentation and what we can do here. We can just write a URL, for example. Inside here we keep this empty because we need to include, okay, we import include from Django configuration URLs. We need to include router dot URLs. Okay, what that does, you see, remember when we put in the main urls.py folder, we came here and we said for this first app go and include all the URLs that it's inside API.urls. Okay, so it's the same method here. We're just telling that we're just adding to our URLs pattern, which is gonna be connected to here to the main project URLs that go inside the router, give me all the registered endpoints or URLs there. Okay, and add them to the pattern. So let's save that, and if we don't have any other URLs like this one, which deals with the function-based view, we can basically just write here router or include or router URLs as it's in the documentations. If we come here, you see URL patterns equal router.urls. What that means is we are telling that, okay, each time our Django project comes to url.py, it will check for a URL patterns. Okay, so here our URL patterns is this. If we don't have this, we can just basically type here URL patterns equal routers or router.urls. Done. We don't need to add this, but because previously we had a function-based view, so we can do it this way. There's two ways to do it. Okay, so let's save this. What we need to do now is we need to try this. Okay, how we gonna try it? We need to run the server and go make a GET request to this specific URL. Okay, so let's open the terminal. Let's clear this and run our virtual environment. activated. And let's navigate to our project folder. It's my API. And let's run the server. .py run server. So we'll wait for it to run. So what we got here, we got an error saying that cars dash specs car spy cannot assign to operator. Okay, this thing is here, so we can't use just the minus sign, we can use the underscore. Okay, save and wait for the server to run again. Okay, what other errors I'm getting here? It's telling me here that router.register missing one required position or positional argument. Okay. Okay, so what's that positional argument? I think I forgot to add something here called or not here when I registered, called base name. Okay, this one here. Okay, so we need to add it. Let's add it. It's a kind of identifier for the router to identify each URL, so we just keep it the same name. Okay, and we save. It's telling me that it requires a view set, which is I think we're getting this error because of something wrong with the default router. Oh, okay, I'm missing two parentheses here, so I think it will work now. It wasn't seeing it as a function. So what next? Let's go ahead and go to the browser and try it. So if we come here, first thing comes the first app, and then we put the car specs. So this is the complete URL. Okay, first app from here. Okay, and then we go inside our application and we add the name that we gave to our URL. What we got here, we got a response, which is good, which means our view set is working. So what we're getting here is authentication credential were not provided. You know what that means. That means we didn't provide a token. So we don't want to provide a token now, so let's change that in our settings. Instead of is authenticated, let's add allow NA, so we can test our view. Remember last tutorial we added two cars specs there in our model, so we're supposed to get them now when we do get requests. Let's refresh, and here we go. You can see here we got the first object, second object, third object. Those are information that we added to our database. So first car, if you remember, BMW with all specs, the second car, okay, and the third car. So as you see, guys, we are able now to communicate with our model through this URL and through our view set. Okay, and as you see here, I have a form to add to my database, a more more information or more objects. Okay, so I can add another car. Let's add another car. Let's say Ford, for example. Ford F50 2019. That's, I don't know what to write here. Okay, let's keep it as normal. Let's say it's 4 doors, but obviously it's not a sedan. Okay, and engine type, let's keep it fuel engine. Okay, and you see this post here. This post is sending a post request to our view set through this URL and telling our view set to go and store this information in our database using our model. Okay, so let's hit post. As you see here, the post sent the new information to our database. And why we got this only because after the post request has been sent there, our view returned the last object we added, which is this object. Okay, but if we go, for example, and we run this URL again, sorry, we can see now we have 4 objects here, including the last one we added just now. Okay, so that's it for this tutorial, guys. We learned how to use view sets and how to implement the serializer there and add the router to our URLs.py so it can handle our URLs and communicate with our views. So thank you guys for your time. Until the next tutorial. Hello everybody, so today we're gonna see how we can get specific information from our database using view set and the serializer. Okay, as you remember the last tutorial, we were able to get, using the view set and serializer, all the data sorry, from our that we stored in our database or model. Okay, so what if I want to get some specific data? What I mean is, what if I want to get only the BMW cars? Okay, or the specs for the BMW 740i only. Okay, how can we do that? Okay, so to do that, we need to rewrite something called view set actions. Okay, and view set actions, as we see in the documentation of Django Rest Framework, for the view set there's multiple actions. There's list, which return all the data that you have in your in the model or database. Create, it's like when you do a post request to create a new object. Retrieve, okay, we use it to retrieve data from our model, which we're going to use today to retrieve specific data from our database. Update is when you do a put request, okay, so to update some specific data inside. And destroy, to delete. Partial update, I'm not sure what's that. I need to check it. Okay, so let's go ahead and rewrite or overwrite, I mean, the retrieve function to do or to get some specific data from our model. Okay, let's head back to our views. Okay, so how we overwrite that? We need to write def the name of the action, which is retrieve, and that this takes some arguments like self, request, args, sorry, and quargs. Okay. So in order to get specific data from our database, we need to use something called filter. Okay, so we need to filter database according to a parameter, okay, or variable, and we need to achieve that by sending this parameter through our URL. I mean, if I come here and I write here the basic or the main URL, and I write beside it BMW, I need to be able to get, obviously the server is off now, it's not on. I need to be able to get only the BMW cars. Okay, so how are we gonna achieve that? First, let's see how can we get this, okay, characters from our URL inside our view. You remember when we used the function based view, we used something called request.queryParams to get this. Okay, there's a different and easier way here, so we don't have to add a question mark, put the name of the variable, and then put the value of it. Here it's simpler than that. Okay, we need to use the argument here quarks to get the parameters from the URL. Okay, so let's assign those parameters to a variable called params equal quarks. Okay, and let's print those params to be able to see how in which format we're getting them, and let's return, we have to return something, so let's return an empty response for now. Okay, and let's save that and go run our server. Okay, how we run the server? Let's clear that. Let's activate our virtual environment. And let's navigate to our project, my API, and run the server. So after we run the server, let's go do a GET request in our so now we're getting all the cars that we have. Let's add some parameters here or something. Let's write BMW, and we need to see how we can get it in our view. Okay, so it's telling me here there's nothing, it returned nothing, which we asked the view to do that, return nothing. Let's go check up here. If you look here in the terminal, you can see that we got something like a dictionary. Okay, it's a dictionary. It's telling us, oh, I received something, parameters from the URL, and the key for that parameter is pk, and the parameter value is BMW. So let's use that. How we can get the BMW from this dictionary? Okay, if we do this here, we give it the key, which is pk, and we save. Okay, and let's go do another request here. We refresh, and we come back. We can see there's BMW here. The BMW here, we need to use it to filter the database from our model. Okay, So let's create a variable okay, called cars here, okay, equal. We need to start with the name of the model that we need to get the data or filter the data from. Okay, what's the name of the model? Is car specs. Okay, car specs dot objects dot. Here we need to use something called filter. Okay, so we do filter, we open parentheses, and inside filter we need to filter according to which field in our model. If we go here, okay, we need to filter according to the car brand, car model, production year. Can use any field here. Okay, we need to filter according to car brand. Okay, so we come back here, we put car brand equal, okay, the params, okay, variable, the pk, which will return the value, this value here, as we saw previously. So this will give us the objects that's inside our model, filtered by the value that we sent through our URL. Okay, now we need to serialize this data before sending it. Okay, how we do that? We just go serializer. Okay, equal our serializer that we defined here, which is the car specs serializer. Okay, and inside the serializer we tell it which data we need to serialize. We need to serialize cars. Okay, and if we know that we have multiple cars with the same brand, okay, like we have many BMWs, many Mercedes, we need to add something here, many, as an argument, and equal to true. Okay, that tells the serializer that, okay, you have many objects for this filtering. Okay, and now we need to return a response, which is the serializer. Okay, forgot here in A, serializer dot data. Okay, so we're returning the data from this serializer. So I think that's it, guys. For now, I think we should go and try it now. Okay, let's save this file, wait for the server to run again, and then go to our browser and refresh this page and see what we get. And here we go, guys. You see, you remember first, without this, without putting a BMW, we got like all the cars that we added to our database, including the BMW, Mercedes, BMW. So we have 2 BMWs here. Okay, and when we wanted to filter, okay, and added the BMW to our endpoint of URLs, we got back only the BMW cars. Okay, so what if I want another car, for example? Let's get the Ford. Okay, so I just want to make sure I spell it right. Okay, Ford, and I got back the Ford. Okay, the same thing, guys, the same method you can use to filter by model. For example, if you want to get car model, okay, by production year, okay, by car body. It's like you're filtering all your database and picking up the specific data that you're looking for. And this is a common thing. If you go to car sites, they give you an option to pick up by year, by model, by engine type, okay, all that, so you can filter through their database and see which cars are available for you, okay, or sometimes per price, okay. So that's it, guys, for this tutorial, and thank you for your time. Hello everyone, today we are gonna talk about how to filter data from our database or models using more than one parameter. So in the last tutorial we spoke about how we can filter data from our model using parameter that we send through our URL, okay. So what if we need to filter by more than, or using more than one parameter, okay? How to do that? So first thing first, if we go to our views.py, we can see that we managed to get the parameter through the quarks, and then we managed to read the parameter and use it to filter by car brand, okay. So if we run the server now, new terminal, let's activate our virtual environment. We navigate to our virtual environment folder, scripts, activate. I just want to run the server and do a GET request to the URL that we used last tutorial, so you all guys be on the same page. Let's run the server, or let's navigate to our folder first. Okay, then on the server. If we go now to the browser, and if we run, as you see here, we send a GET request by writing here or giving a PMW as a parameter. We get back the objects or the data that's where the brand is PMW, okay? Because if we don't send the parameter and we perform a GET request to this URL, we get all the data that we had or we stored in our model or database, okay. So we needed PMW, okay, so we write here PMW, and then we get only the PMW cars, okay. What if I need to go forward and filter using the brand and the model, okay? I don't want to get all the BMW cars. I want to get the BMW cars, plus from the BMW cars I want to get the 740i model. So how can we do that? Okay, let's head back to views.py. So here we need to read, okay, more parameters that come from our URL. So I want to be able to add something like this here. For example, PMW, okay, dash. What's the model? BMW 400 or 740i. Okay. I want to be able to do that, okay, and if I hit enter or if I do a GET request to this URL, it must give me back this object only, okay. So it's gonna be the same strategy that we used to deal with one parameter, but we need to split, okay, what we have here into two parameters and then filter the model. Okay, so how are we going to do that? Before we go to filtering, I just want to say something about what we have here. Okay, you see here, for example, we have a space between PMW and 740i. Okay, because this is how we stored the model in our, or the car model in our data model. So in the URLs, we're not allowed to use space. Okay, all the URL must be coded as an ASCII code. Okay, so in order to perform or to tell the server that this is a space, we need to use an ASCII code that represents the space, and that code is the %20. Okay, so this represents a space. So if I hit enter to perform a GET request to our API, I get nothing. Okay, but if I look here on the server side, what can I see? I can see that I received a parameter. The parameter is PMW-PMW740i. So how can we use this to filter? We need to come here and split this parameter. How we can do that? Okay, let's use a variable called params list. Okay, equal, and this is gonna split the parameters, the parameter that we receive. Splitting it, I mean, we use dash as a separator between the two parameters. Okay, so we need to tell, we need to split this into PMW and PMW740i. Okay, so how we achieve that? We do this. We do parameters or params and we use the key pk, which is the whole parameter or what we received from the URL dot split, and we need to split using the dash sign. Okay, what this will do is will give me back a list, okay, of two we can say items or two values. The first value will be BMW, the second value will be BMW 740i. Okay, now I can use the params list to filter here. Okay, so how we do that? Let's remove params pk, and then we use params list 0, which is the first BMW, okay, the first value of the list, and then we just put comma. What's the next field that I need to filter? Okay, let's get it from here. So the next field is car model. Okay, I need to use a car model, so I come here, put car model equal params list, and we need to use the second value. Okay, so you know that list index starts indexing from 0, so this 0 is the first value of the list, this is the second value of the list. Okay, let's save that and let's try it now. Okay, so if I come here, PMW dash BMW, we use the space as %20, and it's 740i. Okay, if I hit enter now, what I get only the 740i model. Okay, so in this case we filtered by car brand and model. Okay, so this is we achieved the filtering using 2 parameters. Can we do that using 3 parameters? Well, obviously we can do that using the same strategy as well. Okay, we need to read, for example, let's say we need to use a production year. Okay, we can also add here dash 2019, for example. Okay, this is the production year, and we go to our views.py. Okay, so our params list will include the brand, the model, and the production year. Okay, what we need to do after that is add a comma here, add production year, okay, equal params list with the key 2, so to get the third value of the list. Okay, I want you guys to try that and see if it works. And if you have any question, leave it down in the comments. And if you have any problems, just report, guys, and I'll be there to reply to your comments and help. Okay, that's it for this tutorial, guys. Thank you for your time. Hello everyone, in this tutorial we are going to talk about APIView. And previously, in the previous tutorials, we've been using view set from views. It's a class-based view model. So in this tutorial we are going to talk about an APIView, which is another class-based view that we can use with Django Rest Framework. The thing is, in the APIView is a more basic type of view, which means we have to handle a lot of things ourselves. So if you remember, when we started our first app about cars, and we created the API serializer and URLs and views, and in our views we used the model view set from view sets, and in this model, only by doing few line of codes, we've been able to make a GET request and get our data back. And in our URLs we use some kind of router in order to handle our endpoint, which made it easy for us to just add our endpoint names to the router and then include it here. In the API or APIView, we kind of need to do more in order to get things work. Like, we can't just create our view set like here and add just a query set and expect the view to give us some data. No, we have to create, or we have to handle all the requests ourselves, like get, post, put, and delete. Okay, and to do that, I'm going to show you in this tutorial how we can do a get and maybe post request. We'll see, and we'll see how we can handle it and how we add the URLs, okay, or the endpoints. Okay, so to do that, I created a new app, which is, I named it Cars, just to make things neat, because we previously worked on this first app. So in Cars, I just created a new table or model with the same fields. I'm sure you're familiar with this, whoever was watching the previous tutorials. It's just about car brand, model, and production year, and car body, engine type. and then I created the API folder with the serializer URLs and views. Okay, so first let's start by adding the serializer, which is going to be the same as the one we used in the first app. I think I can just copy it and paste it. Okay, this first app API serializer, because we have the same field, so just we have different different models, so I'm sure I can use it. Car serializer. Okay, I just need to change the name, and I need to import the model cars.models, import cars. Cars is the name of the models here. Okay, on the model, sorry. And here let's change it to car serializer, for example, and it's gonna inherit from the serializer model serializer, and we change this to cars. And I didn't add a car plan just to make things simple. If you look here in the model, I don't have the car plan here, so I deleted it. And let's delete the depth. Okay, I'll put a link in the description for the previous tutorial about how the model view set, okay, that we use to create our API. But for now we need to work with the API view. Okay, and next, what's next? Let's come to the view. Okay, inside of our view, first let's import the API view from Rest Framework dot views. Okay, so from Rest Framework dot views, import API view, which we can use, and let's import the serializer. So from serializer, import, and we named it car serializer. And what else we need to import? Permissions and authentications. Okay, we'll see if we need them later, but for now this is what we need. And let's create our view class by typing class, and let's name it cars. Okay, API view, for example, and this will take an API view as an argument, and inside here we can put the serializer class, which is car serializer, and down here we can create our query set. For example, this method get query set, this will get us all the objects. Take self as an argument, and inside here let's create an instance of our object. So car equal, here we need to import our model. So from cars dot models, import cars. Okay, this is the model. So here we just need to get all the objects from the model. So we say, or we write cars dot objects objects dot all and then we return car or cars, let's name it. So we can use this function later instead of doing, cars or object at all each time we need to do a get, it just helps. And so if you remember, this was enough when we used the view set, okay, or the model view set. This was enough for us to get data from our model or from our table database. So we will see now, we will add the URLs and we will test and we'll see if this won't get us anything. So if we go to urls.py, okay, this is just, I'll show you something. See here, for example, when we used the model view set or the view set itself. So here we just created a router and we added our endpoints here. We told them the endpoints which view is responsible for each endpoint, and then according to that we just then after that included our router here. So we can't do that with the API view. In the API view we need to hard code our URLs. Okay, so we need to take URL pattern. Okay, let me just copy this, and inside here we need to just hard code the URLs that we need to use. For example, let me name this cars, for example, and after that we need to tell this URL which view is responsible for handling the requests that come through this endpoint. So let me here import from .views, import what we name it, car API view. Okay, so I need to tell here that this is the view that's responsible for this endpoint, and I must add as view, otherwise I'm gonna get an error. Okay, so it's almost, we deal with it as a functional based views. Let's save this. Okay, and okay, let's go ahead and run the server. Okay, let me clear that, and okay, let's activate the virtual environment first. Scripts. Whoever using Mac, instead of, you can use the same command here, but instead of using scripts, you use bin like this. Okay, activate, and let's clear that, and then let's navigate to our project folder, which is my API, and then let's run the server. Let's wait for the server. Yeah, so we have the server running now. So, and the next step here, we need to include this URL files here, or file, inside our main project file, which is here. This is what I did here. So this will tell our project that we have an app with the URLs file. Include all the endpoints there in the main URLs file. So this is the directory, cars, API, URLs. Okay, so now if I need to access this, I need to type cars app / whatever URLs or endpoints we have here. Okay, so let's compare between the two. Okay, so here, if I go, this is from the car specs. Okay, So if you see, what I got here is all the data that I had in our car specs model, okay, that we added previously. But if we look to our views.py in first app, we see this, we have only get query set. So who handled the serialization, who handled the get request, who handled all that? The model view set, or the view set itself, handled all the requests that we sent through our endpoint, okay, or through this endpoint. And if I type 1 here, for example, I get back this exact object with the ID 1, okay. But if I go to, for example, the cars URL, okay, which is, as we saw, cars app /cars, okay, and I hit enter, I get nothing. It says method get not allowed, okay. So that tells us that viewset is a kind of higher level, which everything is, most of the things are handled for us. If we need to have more control in the viewset, we have to override the actions inside it, so we can have more control, as we did in previous tutorials. In the API view, we have to handle everything ourselves, okay. So to handle a basic get requests, here we need to add a method here, define a method which is get, and this method will take arguments like self, request, args, and quarks, okay. So in this method, or this method will get triggered when we perform a get request, okay. So what we need here to do is, we need, when the client, or when we perform a get request to the endpoint, we need to get all objects and send them back, okay. So how we do that? Basically, we can use this query sets. So we can say cars equal self dot get query set yeah, and let me do this, get query set, and then after that we need to serialize this data. So we type serializer, for example. You can type anything, but I'm choosing serializer just, because we are serializing the data, and we need to use the cars serializer and pass the objects to it. And here in our case is cars, and then we have to add many equal to, okay. After that we need to perform a response, or return a response, and this will take the serializer dot data. Okay, I need to import the response. Just want to remember. Okay, so here can import it here from Rest Framework dot response, import response. Okay, so let's save that actually and wait for it to rerun. Let's go perform the same requests again. So I just want to refresh this, and as you see, we've got the data from our API. I added this previously to the API from the admin panel. Okay, so how I managed to do that, I just in the cars app, I added the cars model to the admin panel, and we did this previously. I just want to show you again. So if you go here to our admin panel, okay, admin. So I added, I went here to cars app, and then inside here I added the cars object. Okay, so as you see now, we managed to get this object from our API. Okay, so if I do here, you see here when we came, we did okay, here when we did the car specs /1 to get specific object with the ID 1, we managed to get it back. But if I come here and I do /1, okay, I don't get anything back. I didn't get anything back actually. It just got me back the same or the last object or the object itself. So it didn't see this. It didn't see it, which means we have to handle it ourselves. Okay, if we need to get specific ID or specific object with the specific ID. So let's try now and add and do a post request. So I can't do a post request from our browser. We need to use Postman. Okay, I'm going to open Postman. Let's wait for it to open. I'm going to try to do a post request and see what I get back from our API view. So this is the post request here. Postman. And see, I have here the same URL that we're using here. And if I do a get request, okay, I get this back. Okay, so let's try post request to cars. And if I do now post request, well, I have here in the body, I have already added some data here. And let's try to do a post request. And says method post not allowed. So it's not handled until I handle it myself. So I need to come here to use that. In order to do post request, we need to add another method named post. Okay, and inside this method we'll add the same arguments that we previously added there. Okay, and then here we need to get the data from our requests. Okay, so we did this previously when we override the create function in our view set. Okay, so I'm just gonna go there and grab whatever we added there and add it here. So it's the same way, we're gonna do it the same way, just there's a small difference here that this needs to be post, it can't be create. Okay, so if we go to the first tab to the views.py, just instead of typing this again. I just want to copy it, just, you know, to save time. So inside here, let me paste this here. Okay, comment out. So because here we don't have the car plan, so I'm going to delete it. So what's this basically? Here, when we do a post request, inside the request here, this argument, it contains the information about the request that we received, the data that's inside, type of request, all that. Okay, so this is the way how we get our data from the request, from the post request, so the fields that we sent. So inside here we're creating a new car object. Okay, so here we change this to cars because we're using the cars model. Okay, and object create, and then we pass here the fields. Okay, the car brand, the car model, and because our data that we receive from our request is dictionary, so we can access it by adding the car data with the key to get the value. Okay, and then we save, and then we serialize the data just to send it back to our client. Okay, so if we save this, I will leave the link in the description for the video where we override the create function of our view set and explained how we did it and how we performed the post request. So now if I go to the browser, okay, you will see the difference. If I come here to the browser and if I refresh this page, as you see now, it detects that now our post or create function is available. So that's why I added those fields here, so I can add new data, for example, to my database. Okay, so let's fill some data, for example, and post, and see we got our data back. Okay, and okay, so one thing I need to just mention here, that you see here, if I put one here after it, I get the same result, because in order to handle this one after the cars, we need to do it manually. Okay, otherwise anything that comes after this, whatever I put there after this, it won't be handled. Okay, and we will talk about this in future tutorials, but for now this is it, guys, and hopefully you understood the idea behind or how to use API views. So that's it, guys, for this tutorial, and I hope you enjoyed it, and if you have any questions, just leave it in the comment below, and thank you so much for your time. Hello everyone, in this tutorial we are going to see how we can get a specific object from our database using APIView. Okay, in the last tutorial we managed to perform a get and post request to our database using the APIView, and in getting the data from our database, we managed to get all the objects that we previously stored in the database using the post request, but we couldn't get a specific object. Okay, so in this tutorial we will see how we can get that specific object using the object ID. Okay, so first thing first, let's run the server by first activating the virtual environment. And now we navigate to our project. And let's run the server. Okay, so after the server runs, we'll go to the browser and put the link here for our cars app, which is cars-app/cars. And as we see, we can get the two objects that we previously stored in the database. But what if we want to get one specific object, for example, the first object, using its ID? If I put 1, as we used to do when we use the model view set, it doesn't work. So what's the way, or what is the technique that we can use to get a specific object from our database? So in order to do that, we need to add some code to our get method inside our API or APIView class. And the code that we must add must handle the parameter that we add after the main URL, which is the ID. At this moment, our view doesn't see anything that we put after the main URL. Okay, so let's first get the parameter. Let's see how can we get this parameter that's that comes after the main URL, and then we see how we can perform a get object from our model or database. So in order to do that, let's go back to our get method, and to get the parameters within the URL, we need to use the request argument. Okay, so we can start by making a variable which let's see, declaring the ID, because we need to use the ID, equal request dot query param, which refers to parameters, and this is kind of a dictionary, so we need to pass the key to the value that we add in our URL. Okay, so it's going to be an ID, and let's print that first so we can see first what we are doing. Okay, let's save and wait for the server to rerun. Okay, so now if we do a refresh here, and okay, as you see, we get an error saying basically that it can't recognize an ID, because when we wrote this code here, the get method is looking now, or the query params is looking now for a value with the key that's ID. Okay, but it doesn't find it. So how are we going to do that, or how are we going to fix this problem? In order to fix this problem, we need to modify the parameters that we're adding to our URL. So we can't just add any number or any variable there. What we can do is we can add a key value pair, okay, like ID equal 1, for example. Okay, and then perform the get request, but we're still getting error, because in order for our view to recognize that this is what we're adding after the main URL is a parameter, we need to add a question mark. Okay, so after we add a question mark, we perform a request, and as we see, if we go back to our console here, or terminal, we see that we have number 1, which is the value of the ID that we added here. Okay, so now that we can get or read the parameter from the URL, we can basically come here and just perform a request to our database saying car equal objects, or mean cars first, dot objects dot get, and then we add ID equals ID, because we are using the ID to get the object. Okay, so we need to do some modification here to this code to get it to work, you know, in both cases when we request all the objects, okay, and also when we request one object. So in order to do that, we need to add an if statement here saying if ID is not none, which means if there's an ID in our URL, an ID parameter, then we need to perform, or we need to get the object that's related to that ID, and then after that we can serialize it. Let me copy this from here. And we mustn't forget to delete many, because we know now that we're getting one object only, so one object, so we don't need many. So else, if ID is none, or we were not requesting any specific object, we need our get method to perform as usual. Okay, get us all the information or all the object. So if we save this and wait for the server to rerun, and now go to the browser and perform a get request, as you see here, we get only the object with the ID number 1. And if we edit this, we put 2, we get the second object. That's great, but we have a problem here. If we go back or delete the ID and we want to get all the object, as we see here, we get an error. And that's because it's trying to read the ID key, okay, and it couldn't find it in the URL. So in order to fix this, we can simply add a try here, okay, or use try except, and in this case, and by adding try except, we solve the problem, because if there is no ID or there's no parameter, then the get will jump directly to this part and then get us all the objects that we need. And okay, let's save it and see. Okay, if we go to the browser now and refresh, and as you see, we get all the objects that we have. And then if we perform a get specific object, then we get it back. And that's it, guys, for this tutorial. I hope it was useful. If you have any question, please leave it in the comment below, and thank you for your time. Hello everybody, today we are going to talk about how to override the create action inside our Django Rest Framework view set. Okay, so what's the create function, what it does? Okay, the create function or action is the action that our Django Rest Framework perform when we do a post request to our API in order to create an object of the new data that we send and save it. Okay, so how we override and take control over that. Okay, so basically let's start by adding a function called create. Okay, and then this function takes the same arguments that retrieve takes. Okay, so we can just copy paste here. Okay, next thing, we need to get the data from our post requests. So how we get that? In order to get that, we need to use the request, okay, argument. So let's get a new variable. Let's say name it, for example, car data equal request dot data. Okay, that the car data will include the data that comes from the post. Okay, the post request. After that, we need to create an object of the data that we receive from our post request. So let's name the variable or the new object new car, and it's equal because we need to create an object of car specs, so we need to use the car specs model, okay, which we imported here. So let's write car specs dot objects dot create, and then we need to add the values. You know that we receive, or our Django Rest Framework receives the data as a key value pairs. So here inside this function here, we need to add the values for the fields inside our model. So we start by typing the name of the field, then the value from our request. Okay, so let's go back to our model. So start by one by one. Okay, so first it's a car car brand. So add the car brand is equal to car data. Okay, and the key for that is car brand. Okay, because when we send it, we'll send it with that key. The next one is the car model. Okay, so we run the same thing, car model equal car data, the key car model. Same thing for production year. Okay, same key. And after that, I think car body and engine type. Okay, so we'll add them here. Car data. And then the last one is the engine type. Same thing, we add the value, the key. I hope I didn't misspell any of these, but we will see in a minute. So after we did that, this is the new car object. We need to save it. Okay, so we do new car dot save. Now what we need to do is we need to send back a response to our client telling telling or sending back the data that we received as an object. So what we need to do is we need to serialize the data and then send it as a response. So let's serialize the data. Serializer, we use the same serializer for our model. Okay, so it's the car spec serializer, and we tell what we need to serialize is the new car object, so we add it here, and after that we return a response with the serialized data. Okay, I think that's it. So let's save this and let's start or run our server. So we start a new terminal. Okay, let's clear this and let's first activate our virtual environment and script activate, and after that let's navigate to our Django project, and then let's run the server. So Python py and server. So now after we get the server running, we need to go to Postman, which we can perform a post request and we see if our create function is working. So let's leave the same data that we have here. Let's just change the model to, for example, M4. Okay, and this is the URL. You know how we got it from the previous tutorial, and let's just send the post request. It gave me an error saying here that serializer is not defined. Okay, let's head back to our code and see what we did wrong here. So here we have serializer. Okay, yeah, I misspelled this. Okay, so I forgot I here. Now it must work. Let's wait for the server to rerun and then we perform another post request. And here we go. So the fact that we received this data back tells us that our post request was successful. We got the data, we saved it, and to verify that we can go to our Django model, or I mean Django admin, Django Rest Framework admin panel, and then we go to car specs and we check our last object, and there, here we go. This is the M4 that we added just now. Okay, so guys, how is that useful, or why would we need to override a create function? Basically it helps if you need to add some kind of restrictions, if you want to check the data before saving it to your database, if you want to do some checking on type of data or values that you have there before saving it. So here you will be able to perform some checks or tests before you save the data. For example, you might tell your API, like, if you receive this kind of model of this data, or if you receive, for example, an object with the production year that before 2000, then don't save it. Okay, and this helps in kind of type of security. If you have an API for, you know, for a some kind of social media, and you want to check for malicious, you know, some kind of posts, malicious data or some specific kind of data before saving it, you know, adding some restrictions. This is basically what you need to, you know, override your create function for. Okay, you can just add an if statement, for example, if you want to check this field on another field, you know, or compare it with an existing field. Okay, if you don't want to duplicate data, so you can perform a check here. For example, if the object that you're receiving is already existed, okay, so you don't want to have two objects with the same value, you know, or have a specific field in common. Okay, you don't want that, so you can perform all that tests here. So I'll see if I might have a tutorial also to just demonstrate an example of how to do some kind of checks, how to access another model inside create and get some data and compare it with the data that we received, and then decide whether we're gonna save it or not. So thank you guys for your time, and until next tutorial. Hello everybody, today's tutorial is about overriding the delete action inside our view set, okay, or model view set. But before we override, let's experience the default behavior of delete action. To do that, first we need to run the server. Let's open the terminal and activate the virtual environment. After that, we will run the server, or let's navigate to our application, my API, and then run the server. So now let's perform a delete action by sending a delete request to our API. Let's use the postman. So inside the postman here, first let's perform a get request and see what objects or what data we have. Okay, so here, as you see, we have the cars that we stored or saved in previous tutorials, and we need to delete one of those of these objects. Okay, so to do that, we just put the ID, okay, and the endpoint on in the URL. Let's put 8. Choose delete this PMWM4, okay, and let's change this to delete, and let's send request. So we don't know what happened. Okay, it was supposed to be deleted. Okay, in order to know that, we need to perform a get request to see if object with ID 8 still exists. So let's do this. If we see now, there is no, the M4 is not there anymore because we deleted it. But if you notice that we didn't get any response from our API to tell us that the object has been deleted or not. So this is one of the reasons that we need to override a delete action. Okay, let's go ahead, let's go there, back to our view, and do that. Okay, so inside our view, to override the delete action, we need to write a method here called destroy. So let's do that. And destroy takes the same parameters or arguments that previous functions like create takes. Okay, it's really simple, guys. We just need to say car to create an instant for an object equals self dot get object, and after that we need to delete this object. Delete. Okay, so that's it. This will do the job for us, and we need to send a response. Return response. The response will tell the front end that the object has been deleted, okay, or the item has been deleted. Okay, so let's try that here. Item has been deleted. Okay, so let's try this and see if it works. Let's save. Wait for the server to rerun and then go. Let's delete the item with the ID number 4 or object with the ID number 4. So we put 4 here, the ID, and we choose delete, and then we send. And as we see now, we deleted the item and we got a response saying that item has been deleted, which is a very good feedback. Okay, another reason why we would need to override the delete action is to do some kind of, check, like if this user that logged in now allowed to delete this or not. Okay, so inside our method here, our action, in order to get the logged in user, we can use the request argument to get that. Okay, so we just need to say here, for example, logged in, okay, user equal request dot user. Okay, and that will give us the user that's logged in now and performing the delete request. So after that, let's change it back to user. After that, we can perform, don't do that, user. Okay, and after that we can perform an if statement, okay, to put the condition like if logged in user is admin, okay, then you can perform the delete action. Okay, and we can, create a response here, message, response message equal, and we put this here. Okay, but if the logged in user is not an admin, okay, else we don't want to perform the delete, and the response message will be, for example, not allowed. Okay, something like that. Let's do that here. Okay, for example, in here we change this to response message. Okay, so now let's try this, or let's test and see if it works. Let's save it, wait for the server to rerun. So inside here, I'm logged in as not as an admin. Okay, so let's perform a GET request again. Okay, so inside here, I'm not logged as an admin. Okay, how to know that? If I go to headers, for example, this is the token that I'm logged in with, which refers to, if we go to the admin panel, go tokens, this is Alan. Okay, so this is not the admin. Okay, and we got here, you know how, because here we have the tokens, and tokens are the unique IDs for our users, and so this is the token that we need to send as a header with our request in order to be authorized. Okay, so this is not an admin. Okay, and I need now to perform a delete action and send it by sending a delete request and see what response I get. Okay, let's choose the item with the ID 3 and choose delete and send, and as you see now here we get a response says not allowed. So this is like one of the reasons that we need to override and delete actions. Also there is many reasons, depends on your applications, but basically this is how we do it, and will give you more control on your API. So that's it guys for this tutorial. Thank you for your time. Hello everyone, in this tutorial we will override the update or put method, demonstrating what needs to be done when performing a put request to our API. So first we get the object that we want to update from our database. Then we take the fields that need to be updated and assign the new values to them. And after that we save the new object and then return the updated object. And to demonstrate that, we will use two of the apps that we created previously. One with the nested data and the other one without nested data. And let's start with the cars app. And inside here, if we look at the cars model, it's a symbol model that represents car specs. And if we look here, we can see that we have a car brand, car model, production year, body, and type of the engine. So inside, if we go to views.py, we can simply see that we previously managed to override the get function or method and the post method. And now we need to override the put method. So let's define put method and add the parameters self, request, args, and keyw args. Okay, and then after that, inside this method, first thing we need to do is get the object from the database. So to do that, let's name it car object, for example, and let's use the model name, which is cars dot objects dot get, and that will get us the object that we need to update. Obviously, because with the put request, the object ID is included in the URL at the end of the URL. So this is how this method gets or knows which object to get. So after that, we need to extract the data from the request. So let's just name a variable data equal request dot data. after that, we need to update the object values to the new values that we received from the request. So in order to do that, we simply say car object dot, we start choosing the fields one by one. So if you go back to the model, we start with car brand and then car model until the end of the field. So we add here car brand equal data, and we put here the key of car brand value, so which is car brand, and the same thing goes for the rest of the fields. So dot car model equal data, and here we add car model key. Third one is production year equal same thing data, and we add production year, and what else, I think the body and the type. So car object dot car body equal data and the key, and the last one is the engine type. So engine type equal data, and we had here engine type. Okay, so after we updated the fields, we need to save the new model. So we simply say car object dot save. After we save the car object, we serialize the data of this object, then we return the serializer or the serialized data. So let's do that. Equal cars, we will use the car serializer, and that we created in previous tutorials, and simply here we add the car object, and then we return a response with the serialized data. Let's test the put method now. In order to do that, first let's run the server. So we type python manage.py run server, and make sure your virtual environment is active. So now the server is running. Let's go to the postman, and inside here we need to add the URL for the cars view or cars model. So it's cars app /cars. Okay, let's perform a GET request and see what models we have or what objects we have. And as you see here, we have only one object inside our database. That's PMW car with the model and year and other specs. So I want to update this information, and in order to do that, I need to request the object by its ID. So I'll do this. I'll add it to the URL, the ID of the object. So let's see if we can get it. As you see, we got it back the same object. And now we need to perform a put request, including the data or the new data that we need to add to the object. So let's change this to put, and inside here I'm just gonna copy the data or the JSON data from here, because the data that we need to send, it needs to look like this. Okay, It's simply an object with the fields inside and with the new values of each field, or value of each field. So let's, for example, update this year to 19, and let's say this is M4. And let's leave the rest as it is. So now I need to perform the put request. So if I click send, as you see, I got my object back with new data, as you see here, the M4 and 19. And as you see, guys, we managed to override the put method and update a specific object in our database through a put request. The next case we need to handle is updating an object that includes a nested data. And for that we will use another app here, which is the first app, and we created that in previous tutorials. And inside here, if we go to models.py, we can see that we have two models here, the car specs and the car plan. And these models are linked using many-to-one relationship represented by car plan field here and the foreign key. So here, if we perform a GET request, we will see that we have a nested data inside car specs. So let's see that. So I'm gonna add the URL here, which is first app / car specs, and I'm gonna perform a GET request. And as you see here, we get two objects, and inside each object we have the car specs plus the car plan, which is an object nested inside the car specs object. So in order to update, for example, the first object here represented with the ID1, I need to handle the update method or the update request differently. And in order to do that, let's go to our view here inside views.py, and inside here I'm going to define an update method. And why it's update here, not put? And that's because we are using a model view set from view sets here, not an API view. So I meant to use two examples to show you guys how to override a put method inside an API view and do the same thing inside a model view set. So let's carry on with the code. So here, this method will take the same arguments, self, request, args, and key w args. And first thing we need to do is get the object that we need to update. And let's name it car object. Use the same name. And it's equal to self.get object. So that will be enough to get the object. When we use the API view, we had to write the name of the model, for example, cars.objects.get. But inside a model view set, we just need to say self.get object. After that, we need to extract the data from the request. So we simply type data equal request.data. The next thing we need to do is get the car plan object. So to do that, let's name it car plan equal, and we'll use the car plan model name dot object dot get, and we'll use the plan name for that. So plan name equal data, and we'll give it the key plan name. So we'll use the plan name to update the car plan. After that, we assign this value to the car plan field. So we say car object dot car plan equal car plan, and then we add the rest of the fields, which is the car brand, car model, and the rest of them. So because they are similar to the previous example, so I'm just gonna copy paste them just to save time. So here we managed to add all the objects, or all the fields, I mean. So the next step is to save the model. .save. After that, we serialize this object using the CarSpecs serializer. We pass the object, and then we return the serialized data. So that should do it. Let's save it and wait for the server to rerun. And now if we go to Postman, and let's try to update the first object. So let's request the ID. So now that we have the first object, we need to include the new fields that I need to update. Let's add the curly brackets here. So these are the basic fields from this object, and we need to add one more field, which is the plan name for the car plan. And because this object was linked to the second plan, I want to change that now to the first plan. By changing the plan name. And I can also change the other fields. So let's say, for example, it's M4 2019, and let's change this to fuel, for example. And now we perform a put request, and all the fields or all the data should be updated. So let's do that. And as you see here, we got the updated object back with the new data. As you see here, the nested object is the first plan, not the second plan anymore. And the rest of the fields also have been updated. And now some of you might be wondering, what if I want to update one field only, like the production year only, or the model? Do I need to send the whole object just to update one or two fields? And the answer for that is no. You can update one field or two fields only using what's called partial update or batch request, which is listed here if you see batch, and that's responsible for partial update. And we will be talking about that in the next tutorial, how to perform a partial update one field or two fields inside model view set and API view as well. And we will see how can we implement the partial update inside the update method of our view set and API view without the need to override the actual partial update method. So that's it guys for this tutorial. I hope it was useful, and until the next one. Hello everyone and welcome to a new tutorial. Today we are going to see how we can link or create a relationship between two models in our database. And that's a very important feature because it helps us improve our database structure and make it more flexible and reliable. So to do that, first let's create, we previously created this car specs table or model, which includes some information about the car. So now let's create another model that tells us if the car has warranty or how many years of warranty, or if it has a finance plan. Okay, let's do that. Let's start by creating class and let's name it car plan. Okay, car plan, and this will inherit from models dot model. And let's add some fields here. So first field will be like the plan name. Okay, so the plan name, and this will be a char field, and let's give it a maximum length of 20. That will be enough. And the next one will be years of warranty. Okay, years of warranty, and this will be, let's choose a positive integer, and let's give it a default value of 1. So it's 1 year of warranty. There's a default value. Finance plan, and here we're just gonna write if it's available or not. Okay, it's gonna be char field, max length 20, and let's give it a default value of unavailable. Okay, and let's define here string that will return the plan name. Okay, so right now we created this model here. Okay, for example, if I have a car, or if I'm buying a car, I need to know if this car has a finance plan, how many years of warranty, insurance, for example. And all this data must be accessible when I, for example, perform a GET request to get the information about the car. So in order to achieve that, we need to link this table here, or this model, to this model here, which is the car plan. Okay, to do that, we need to add another field here that will represent the relationship. And this field, let's name it, for example, car plan. And we're gonna use something called foreign key. Okay, that will take an argument. First argument will be the model that we need to link this car specs model to, which is the car plan. Okay, the next argument here will be on delete. Okay, so we have to define what's going to happen to this model if we delete, or this object if we delete the object, the car plan object that's linked to it. Okay, so we just need to, in this case, let's say if we have a car that has information about years of warranty and finance plan. So deleting this object from here, or a plan, mustn't affect the object in the car specs. I mean, if we delete the plan, if we have a plan in our database and we delete it, and that plan was linked to one car or two cars or more than that. So deleting the plan mustn't affect the cars object. That's why we need to define here on delete, and we need to choose an option which is set null. Okay, what that means exactly, it sets this field here to null if the object that's linked to it was deleted. Okay, so, and in order to get that to work, we need to add one more argument here, and which is null equal true. Okay, so with that being done, we are all set in our models.py. Okay, so let's save it, and to get that to work or to reflect on our database, we need to do the migration. So as we know, we spoke about this in previous tutorials, every time we edit our models.py, add things, add models, add fields, we need to perform the make migrations and migrate in order to build those fields and tables in our database. Okay, so to do that, let's open the terminal and let us activate the virtual environment. Activate. Okay, I misspelled this. And let's navigate to our project folder. And let's run the make migrations, which is Python manage.py make migrations. Okay. So the migrations were made, and now let's migrate. So now that our database is set and we have those tables in our database, we need to access them through our admin panel. So to do that, let's add the new model that we created, which is car plan, to our admin panel. Okay, and this is in the admin.py file. Just need to register it and save. And now we can run the server and see and add some data to the car plan. Okay, so let's run the server. And now we can go to the browser, and here this is the admin link. Okay, and let's sign in my API, put the password, and now as you see we have another option here, which is car plans. Okay, and here we can add some data. Okay, let's name this plan first plan, save it. Let's add another one, just name it second plan, and this will be 2 years and finance available. And let's add another one, let's name it third plan, and this will be the 3 years warranty and finance available. Okay, so now if we go, now that we saved this in our database, if we go to the endpoint of car specs, which is this, okay, if we check here, So what we don't have any information registers. We didn't store any cars yet. But what we can see here is we have the car brand, car model. Those are the normal fields for the model, okay, for the car specs model. But we don't see the field that we added recently, which is this field, the car plan. And that's because we didn't add this field in the serializer. Okay, so guys, always remember, if you add any fields in your models, you have to edit your serializer to accommodate that field, because the serializer is like a kind of a link between your view end or your front end and the database. So let's add here the car plan field and save it. I'm waiting for the server to rerun. Okay, and now if we go here and refresh, as you see here, we have our car plan field added. And if you notice here, it's a drop down. Okay, and that's very cool because it's already linked the car specs to the car plan model and give me all the available plans. So it's easy for me now. I can just choose the first plan, for example, fill this information here about the car, and then just save my new object. Okay, and as you see, the data we got back includes all the fields of the car specs plus the car plan. But what is this number that we see next to it, and what's this value? Okay, this value represents the ID of the car plan object. For example, the first plan has ID of 1, second plan has an ID of 2, third plan has ID of 3. So if we chose second plan, we would see an ID of 2, for example, here. Okay, so this, we can use this ID to, for example, after we receive this information, we know that the car plan has this ID of 1. So in order to get the information about this car plan, then we do another request with this ID to the car plan model, and we can get the data back. That's not practical because that requires 2 requests in order to get the whole information about this car. So the good option that Django Rest Framework provides in order to get the nested information here for the nested relationship is pretty simple. If we just come here and add something called depth equal to 1 and we save it, then you will see now that we will be able to get the information about the car plan also within the JSON data that we received from or the dictionary that we received from our database. So if let me do another request here. Okay, and look now, instead of having the 1 only, which is the ID for this object, we have the whole object, and there will be more practical to read if you're in the front end receiving data, so you don't have to do 2 requests. Okay, so now we have a better way of viewing our data, more readable and accessible. But if you notice here, we lost the car plan field after adding the depth 1, the depth equal 1. Okay, and we can't add it anymore, which means if I want to do a post now to add, for example, a new car, okay, let's say M4, yeah, and if I do a post request and to save the data, so I'll be able to save the data, but the car plan will be null and I won't be able to edit. And even if I do it through, let's say, a real life scenario or application, which we can demonstrate using the Postman. I mean, if I add here another key here, I have all the car specs model fields added. If I have, I need to add the car plan field to it, okay, and I'm supposed to be able to give it the ID of the car plan, and it will be enough to save it in normal scenarios. For example, if I give it an ID of 2, this I'll get the second plan, for example. But if I do that now, okay, and if I perform this post request now, I'm gonna keep it on top just to make it easy to read. So it's gonna be the same sequence. If I do a post request, okay, to store this object in the database, let's send. So I get back a response that tells me that you have been able to store this object there, but it didn't read the plan. It didn't take it. It didn't see it as you know, as a valid field. So the solution for this is to override the create method or action in our view, and I have a video about that, a tutorial where I explained how to override the create function. Okay, so we're not going to go through that again, but we're going to do some modification to the action in order to be able to accommodate the new field. Okay, so if we go back to our views, so there's the model views. See, this code is from the previous tutorials where we overrided the retrieve and the create and destroy function. Okay, so let me comment out the create function. Okay, so here I have all the fields that's coming from the endpoint or from the request. So the only field I need to add is the car plan. Okay, let's add the car plan field. And the car plan field, it's not a string, it's not an integer, it's an instance of a car plan object. Okay, so the right way to do it is to get the object of the car plan model, okay, that's its ID equal to the value that I'm getting here through my request. Okay, so to do that, we can simply first import the car plan model here. Okay, I already imported it, and we can come here and say car plan dot objects dot get, and inside get we need to pass the ID of that object. So the ID of that object, it's here. We can get it from the car data that we're receiving through our request. Okay, in this case we'll be able to get the right data for this field. Okay, so we need to save this, wait for the server to rerun, and if we open our Postman now and we add another car, for example, let's choose M3 for example, let's edit this. Okay, and all fields are set. Now if we perform a post request to this, so we get an error saying not enough values to unpack. Okay, let's see if we made any mistake here. Oh, we have to tell here that this value is for the ID, so need to add an ID equal. Okay, wait for the server to rerun. And if we come back here and we perform the post request, as you see, we have been able sorry, to save the object plus the car plan object that's linked to it, okay, or related to it. So basically this is how you can do it, guys, to solve this problem. So I think that's it for this tutorial, guys. Thank you for your time, and ask if you have any question, and until the next tutorial. Hello everyone, in this tutorial we're going to talk about one-to-one relationship, and it's basically a way of connecting two objects that are uniquely linked to each other, okay? And that means if we have an object number one and object number two, when we use the one-to-one relationship, object number one can only be linked to one object, which is the object number two, and the same case for the object number two can only be linked to object number one, okay? And to make this clear, or to help you understand it better, we need to demonstrate a real life scenario with it, okay? And I chose for that the post example, okay? Like when you have a social media or web application or blogging application, web application, or some sort of post, you know, platform where you post some article or share some information, and you get some likes on it, like you have like, you have dislike, and all that stuff of rating, you know. So what I did here, and I didn't want to go through all that in this tutorial because we've done that in previous tutorials. So I created a new app in our project. I named it Posts, and inside this app I created two models. First is the posts, which is two fields. One is the post title and the second one is the post body. And I created another model which is the post rates, and that will contain likes, dislikes of our posts. And for each one of these models, I created a view that will handle the requests through our URLs, okay, or the URLs that we configure. So I configured two URLs, one for posts and the other one for post rates, okay? And inside the serializer, I just set up the serializer, one serializer for each model, including the fields that we need to use, okay? So to get started, I just want to run the server at the moment and show you the models in our admin panel, and then we'll take it from there. So let's run the terminal, and inside our terminal let's first activate the virtual environment. And after that, we'll run the server. Or let's navigate to our project folder and then run the server. And we'll wait for the server to run, then we'll go to open the browser. Sorry, then we'll go to the admin panel, And as we see here, I have the post rates and I have the posts. Okay, we're gonna send and receive data, store data, and sending a post request and get request through our postman. Okay, not through the admin panel, because it's better to use the postman to demonstrate a real life scenario when you posting and also when you getting the posts. So first, before doing that, let's test our endpoints. Let's come here. This is the endpoint or the URL for posts. As you see here, I can create a post, and the other one is post rates. Okay, let me see why it's not working. Let's go to URLs. Okay, we didn't assign the right view for this, so if we save now and refresh, okay, if we go now, let's refresh this page and you get the last slide. Okay, so now next step is to link these two models using one-to-one relationship. Okay, so what I want to do here is link this post rates to the post. Okay, so let's add a field here and name this field rates. Okay, and this field will be will represent the relationship. Okay, dot one-to-one field, and inside the field, the one-to-one, I need to specify the model that I need to link, which is post rates, and I need to specify what will happen on delete, which is I wanted to delete the actual model. And basically, guys, that's it. Now we managed to link post rates to posts, or posts to post rates in a one-to-one relationship. Okay, let's see how it works. Let's save this. So because I added another field here, okay, it's telling me here that name post is not defined. Okay, obviously because of this needs to be on top. Okay, so we'll save this, and because I added another field here, I need to run the migrations. Okay, it's telling me that I need to give it a value, a default value. So let me do that here, and we'll say just keep it this way. Okay, and now we managed to add the other field here. Okay, let's run the server again. Okay, that's cool. So now our two models are linked. So let's say in real life scenario, I'm creating a post. Okay, so I want to send type a post title, post body, and send it. Okay, what I'm expecting from my API is to go create first a post rates object and then create the post object. Okay, so where can we handle that is in our views. So in our views, we need to override the create function, and we do that by declaring a method called create and adding the arguments to it. Those are the arguments, and then inside we need to first get the data that's coming through our post request, and to do that we can simply let's say post data equals request dot data. And after that, we need to create, as we said, a post rates object. What we do is we say new rate equal post rates dot objects dot create, and then we pass the parameters. So what's the first field in our post rates model is rate as likes, and the second one is dislikes. So we add here likes equals post data, and we add here the ID, which is gonna be likes, not the ID, I mean the key, and the second one will be dislikes equal, and then we also type the dislikes key. Okay, and then we simply say save to save it. And after we created the rates object, now we create the post object. The post object, let's say new post equal posts, which is the model, dot object dot create, and then inside it we pass the parameters, which is first one is the post title, equal post data, and we pass the post title key. Second one is post body, and it's equal post data, and we'll pass the post body key. And the last one is the rates, or rate, let me make sure, rates. You remember rates is an object, and it's actually the object that we just created and saved here. So we simply type new rate, and then after that we save the new post, and then we serialize the data, but let's name it Serializer equal post serializer, and we pass the new post, and then we return response serializer. Okay, so this should do the job for us. So what we've done here basically is we created the rates object, and then we created the post, and we assigned the rates object to the new posts. And this is what should happen when we send a post request with the new post details. Okay, so let's save this. And then let's go to our postman. So we add the link for the posts, which is posts Let's make sure this is the right link. Yeah. So now to perform, let's perform a GET request just to test. Okay, we have no data yet. So to perform a post request, we choose post here. And normally inside the body here, we go to form data and we add the fields as a key value pairs, which means we add post title, the title, post body, the body, and then rates is an object that must include how many likes, how many dislikes, and we can't edit in this field here. Okay, so in order to perform this post request, we need to choose another option, which is the row. Okay, inside row we can structure a JSON object and then send it as a post request through our post request. So let's start structuring the object that we need to send. So what we need to send first, we need to send the post title. So we write post title and its value is first post, and then the second field is post body and its value is let's write, for example, this is the first post. And now when we come to rates, so rates is an object. We open another curly bracket and inside it we add likes. Let's say 10 likes this post has, and we add dislikes, which is, let's say, has 1 dislike. Okay, so this is the data structure or the JSON object that we need to send. So I think I forgot to add something inside our view. Okay, if we go here inside our view, the way I extracted the data from the post request here or from the request data is wrong, because here I said post data likes. In this way, likes is supposed to be in this scope with the post title and post body, but likes, in order to get likes, we need to access this first, the object key, and then the likes. So to do that, we just need to add here another square brackets, and inside them we'll type rates, and here forget to type this post data, rates, and this is supposed to do the job for us. Let's save. And the serializer, I need to add here depth equal 1 to see the nested information or objects. Okay, so if we go now to Postman and then we perform the post request. Okay, let's see what error I'm getting here. You call the URL via post, but the URL doesn't end with a slash. Okay, okay. I need to put a slash here. And let's see the error here. You said you pass the serializer instance as data, but probably meant to pass serializer to data. Okay, let me see here in the views. Okay, this is my mistake here. Let me save it. It's good to have these mistakes so everybody can learn. Okay, let's perform it now. And as you see, guys, we managed to perform post request, and we posted first post and the post body. Okay, but the reason why I'm not seeing the rates here, because I think I didn't add it here. Okay, so I'll go here, I'll add the rates. Okay, and then we save. And if I go back here and I perform a GET request, okay, I'll be able to see the two objects. One I previously added, and this is the new one that we added, first post. This is the first post. And as you see here, guys, we managed to perform a post request, and we handled in our view the post information and created a new rating, and we assigned that to our post. So in this case here, if we go to the admin panel now, let me add another post, guys, so it'll be clear for you. Let's say this is the third post. Okay, 6 for example, and let's send it. I managed to get it back. So this is the post ID, this is the third post information, and the rates. This is a real scenario where you could use in your application or your website. What one-to-one does is, I can't, for example, let's perform a GET request. So I'll explain to you something to you here. Now we have 3 objects here. For example, I can't, or one-to-one relationship doesn't allow me to assign this object with the ID 5 to any other object except the ID, the post with the ID 4. And if we go to the admin panel now, just to demonstrate that, for example, if I go here to posts, I see I have 3 posts here. I want to add a new one. Okay, so I'll add here, for example, hello, and let's say this is a test post. Okay, and if I come here and I choose, for example, this post trace object here, which has been assigned to another post, and I click save, you'll see I get an error here saying posts with this rates already exist. So I previously added a post that's linked to this object, so I can't add this object to another post, or this rates object to another post, because it's one-to-one relationship. And that's it, guys, for this tutorial. Hopefully it was useful. If you have any question, please leave it in the comment below, and until the next one. Hello everyone, in this tutorial we are going to discuss the many-to-many relationship. And in order to understand the many-to-many relationship, let's compare it with the many-to-one relationship, which I made a video about previously, and I will leave a link in the description for that video. And for now, let's see some graphical explanation that will help us understand the many-to-many relationship. So in the many-to-one relationship, we can link multiple objects of a model 1 to one object of a model 2. But each object of a model 1 can be linked to only one object of a model 2 at the time. For example, a post can have multiple comments linked to it, but each comment can be linked to only one post at the time using the many-to-one relationship. While with the many-to-many relationship, we can link multiple objects of model 1 with multiple objects of model 2. An example for that is a school system where you will link students with the modules that they are studying. So to implement the many-to-many relationship in our API, let's create a new app and name it school. And to start, first let's activate the virtual environment. And then let's navigate to our project folder, my API. And inside here, let's run python manage.py start app. And let's name it school. And as you see here, we have the school folder available with the files inside it. So let's go to models.py, and inside here I want to create two models. First model is modules, which what the students will be studying. So let's name it modules, or you can name it module, it's fine. And inside here I'll have three fields. First one is the module name, so I can say module name, and it's going to be a character field with max length. I think 50 will be okay. And the second one will be the module duration. Okay, so in months, for example, how long this module takes, how much time was allocated to this module. And let's have it as an integer, or integer field, and the second one will have, or the third field will be the classroom. Okay, so let's have a class room, and that will be also a number referring to the classroom. And let's return the name of the module. So an str method. Let's return the name. So this is the first model that we need. The second model that I would like to create is student. So let's have it. Student. You can name it student, students, whatever. Let's name it students because we already said modules there. So, okay. Sounds better. And inside here, we're going to have the name, which is the student's name. And it'll be correct field. The max length of, I think, yeah, 50 is enough as well. And the second field will be the age, and it's in integer. Third field will be the grade, and it's an integer as well. And the last field is the field that we need to use to link the modules model with the students model using the many-to-many relationship. So we can simply say modules equal models dot many-to-many field, and inside here we just specify which model we need to link to, which is the modules. And let's return the name of the student. And now, as you see, the models are ready. So let's save this and let's go to the admin.py and add these models there so we can see them in the admin panel. So let's import them first. We need to import the modules and students. Okay, and then we register them. Register the first one, the modules, and then we register the second one to the student. Okay, let's save that. And now let's add the new app that we created to our installed app, so our API can acknowledge that. And let's write here school and save it. And then now we should run the migrations. So Python by make migrations first. And as you see here, we have done 2 migrations, the modules and the students, and then now we can run the migrate. And now the migration is done. So in order to see this in our admin panel, let's just run the server now. And let's go to the browser. And refresh. And as you see here, we have our app here, the school, and we have the two models that we created. So if we go to the first one, and let's create some modules here. For example, let's start by, for example, math, and let's say 4 months, the duration, classroom number 1, and let's save it, and let's add another one, which is physics, for example, physics, and it's also 4 months, classroom 2, and one more. Let's, for example, add the history, and duration 3 months, for example, and the classroom 4. And now if we go add a new student to our database, basically we can add the name. Let's say, for example, Alan, and the age is 18, grade 12. And this is the interesting part. As you see here, we have 3 options, which are the modules that we created. And as you remember, in the many-to-one relationship, we used to have here one option. Okay, so we could add one field only, but in this case, with the many-to-many relationship, I can add all the modules that I've created, link them to this particular student. So I can just mark them all using control and choosing one by one, or command if you're using a Mac, and then I can simply save. And if I open this again, I'll see that it's saved, and I have 3 modules linked to this user. And I can add another student, for example. Let me go back to students. I can add another student, for example, Mark, and then age of 17, grade 11, and then I can choose that, for example, Mark is not doing math, is doing history and physics only, and then I can save it. And now I have 2 students with different modules linked to them. And now let's create the necessary files that will allow us to access the school app from a custom endpoints. So let's go back to VS Code, and inside the school app I'm going to create a new folder and name it API. Inside here I'm going to create 3 files. The first one is the Serializer .py, and the second one will be views, and the third one will be URLs. And let's start with the Serializer.py. And first we need to import the Serializer from Rest Framework. So let's type it out. Serializers. And then we need to import the models from our models.py file. And they are modules, students, and now let's create 2 serializers, one for the modules and one for the students. So let's create a class and name it modules serializer, and it's going to inherit from serializers.model serializer. And inside here, let's specify or add the class meta. And let's add the model name, which is modules, and the fields, which are ID, because we need to get the object's ID. And let me check the model. So we have module name, module duration, and classroom. So we need to add that. So here, module name, and then module duration, and then classroom. Okay. And let's create a second class, and it's student serializer, and it's going to take same thing, the model serializer. And let's first specify the class meta, the model name will be students, and the fields will be the ID, name, age, and grade. And the last one is the modules. Okay, I think that's it. Let's check the model. So it's name, age, grade, and modules. And I'm gonna get here depth equal 1 to get the nested data. Okay, so let's save this. And the second thing we need to do is to add the views classes inside views.py. So let's go to views.py file. Inside here, we need to add two classes. One is for the students and one for the modules. And we will use a model view set. So I'm going to copy paste the code here just to be more efficient and save time, because it's just a simple code. So we're importing the view set and then the response, and then after that we're importing the models that we need to use, and then which is the student's model and the modules model, and then we're importing the serializers from the serializer.py file in order to use them inside our views to serialize the data. And then we create the views classes. So first class or first view will be the students view set, and it's a model view set. We specify the serializer that we need to use, which is the students serializer, and then we add a normal get query set method, which will take all the objects from the students and then send them back to us. Okay. Okay, so the second thing, or the second class, is the modules. You can just simply paste here and then just edit it. So it's the modules view set, and the serializer will be modules serializer. And inside here, we can just type module, and we get query set from the modules model and module here. So basically that's it for now for the views.py. Let's save it. And now let's create the endpoints for the school app inside urls.py. And again, I'm gonna paste the code here because it's pretty simple. And here we're using Rest Framework routers to specify or add the two endpoints that we need and allocate a view set for each endpoint. So as you see here, we're registering a student as an endpoint with the student view set and module with the module view set. And then we including them inside the URL button. So let's save this. And then let's go to the main project urls.py file and then include the endpoints that we created inside the school app inside the project urls.py file. So to do that, let's copy this. And then here we can initiate the endpoint or start the endpoint with the school, referring to the app. And then we replace the posts with the school, which refers to school app. So here all the URLs or endpoints inside urls.py will be included. So let's save this file now and check and I'm getting this error here that says cannot import name student serializer because I think I misspelled it. So let's see serializer.py file, and I can see here I forgot to put an S. So let's save this and wait for the server to rerun, and our server now is running. And now it's the time to test the endpoints. So I'm going to run Postman here, and I'm going to perform a GET request to the student endpoint. So I'm going to type here school/student. Then I'll send the request. And as you see here in the JSON data, I'm getting back the two students that we added in our database using the admin panel, Alan and Mark. And then also I'm getting as a nested data here inside the student object the modules that each student is taking. So that's very good. And now I can also request a specific student by just adding its ID as you see there, and then perform a GET request. And now I'm getting only Ellen, or I can get Mark as well. So by changing the ID, so I'm getting the other student. And the next thing we need to do is to handle the post request. And in order to do that, first let's add a JSON object here to represent the new student that we need to add to our database. Okay, and for that I'm just gonna copy this here, this object, and just do some modifications. So we don't need the ID. We'll add a new name, for example John, and then let's say John is 16 and he's in grade 10. And for the modules, I'll just need to add an array of objects that represent the name of the module only. Okay, so what I'm going to do is I'm going to remove the extra data here. Okay, I'm just leaving the name of the module because we will need to query using this name. So this is basically the data. Let's edit the URL. This is the object that we need to add, or the new student that we need to add with the modules that will be allocated to this student. And now if we perform a post request, I get the user object back, which means the user or the new user has been created and saved in our database. But if you look here, no modules have been added. And to solve this problem, we need to override the create function inside our view. So let's do that. So we go to views.py. Inside here, we need to add the create function. So let's define the create function and add the arguments that we need. And inside here, first thing first, we need to extract the data from the requests. So let's say data equal request dot data. Okay, and after that we need to create a new student. So let's say new student equal student the model name dot objects dot create, and inside here we need to add the fields. So if we look at the model here, we need name, age, grade, and modules. So let's start by adding them. Name equal data, and we give the key name, and then after that age equal data, and we give the age. We do the same thing for the grade, and this will be enough to save the student. So let's do new student dot save. So now that we saved the student, we need to add the modules that we received from our post request to this particular user. And in order to do that, we need to loop through the list or the modules list, and then add each object that's represented by the module name inside this list to this user. So to do that, we say, for example, for module in data modules, and that refers to this here. So this will give us back the list. What we'll do now, we'll grab the module object from the database. So we'll say module object, for example, equal modules. Let me just make sure I'm using the right name. Yeah. Okay. So modules dot objects dot get, and inside here we'll use the module name equal module, which is this one, and we'll add the key module name. So what we did is we looped through this list, and for each object inside this list we grabbed the value associated to the module name key. So now, after we get the object, we need to add it to the new student object. So how we do that? We simply say new student dot field modules dot add, and then we add the module object. So this for loop will go through each object inside the module list and add it, add the module object associated to that module name to this new student. And when that's done, we need to serialize the data. Type serializer equal student serializer, and then we add the new student, and then we send or we return a response with the serialized data. So serializer.data, and that should do it. So let's save it and let's go test this view inside our Postman. So I'm going to just change here the name, for example, make it Steve, and leave the rest as it is. And then now I'll perform the post request, and as you see, I got the new student object plus the modules associated to that student or allocated to that student. So that's it, guys, for the many-to-many relationship. So we saw what's the difference between the many-to-many relationship and the many-to-one relationship. We implemented the many-to-many relationship in a practical example, and we saw how we can perform a get and a post request to handle the data. And in the next tutorial, we'll be talking about the update method, how to override it in order to get our data updated. And until the next one. Hello everyone, in this tutorial we are going to learn how to use the string related field in our serializer to represent the target of the relationship between two models using the str method. And to demonstrate that, I created a new app called Alpams using python manage.py start app, and then inside the models.py file I created two models. One is Alpam, the other one is track, and this first one will represent the albums or specific of a specific artist, for example, and the tracks inside each album will be represented by the model track, and they are both linked to each other, as you see, using a foreign key, which is a many-to-one relationship. So in this case, for each model I can have, for each album I can have multiple tracks, okay, which makes sense. So we need to find a way when we request or we perform a GET request to the albums, we need to find a way to get all the tracks related to this album. And in order to do that, we need to use something called string related field in our serializer, which relies on the str method inside our track album. So if we go to the serializer, I have a simple serializer here that serializes the data between client and our API. So if I go now and if I run the server and perform a GET request to the URL that I configured here inside urls.py, so I configured an album to get the albums, track to get the tracks using the default router, And if I use the album link to get all the objects or the albums that I stored already, I'll be able to get all the objects or all the albums, and each object will be represented by its ID, album name, and artist. So to do that, let's run the server first. Obviously, after you create the app, I did create this app just to save time during the video, because we've done this before. But when you create the app, please, after you add your models, make sure you run the migrations. Python manage.py make migrations, then migrate, then you can run the server. So I'm just gonna run the server now. Python manage.py run server. I'm gonna wait for the server to run, and then I'm gonna open Postman and perform a GET request to this URL, music albums. Okay, so I'm gonna open the Postman. I'm gonna open a new tab, and I'm just gonna type the link, which is music /albums. And then if I perform a GET request here, I can see that I have two albums here that I previously stored in the database, album 1 and album 2. And these two albums here, for example, the album 1 contains 3 tracks, but it doesn't show here. So I'm going to find a way, or I'm going to use the string related field inside the serializer to represent or to show the target relationship using the str method. So to do that, I'm just gonna go back to my code and open the serializer, and inside here, inside our album serializer, because we need to get the related tracks when we perform a GET request to the album serializer. So inside here, I'm going to declare a variable called track equals serializers dot string related field, and inside here I'm gonna add many equals true, because I have many objects, and also because of the type of the relationship that I'm using, which is many to one. So now I need to add this variable here to the list, or to the field, and by doing that, now if I perform a GET request to the album link, I'm supposed to get the album. Within the album, I will get all the tracks, or within the album object, I'm supposed to get all the tracks that are related to that album. So I'm going to save this, and obviously, just to mention, each track will be represented by this str method, which takes the order of the track and the title of the track. So I'm going to head back to the Postman, and now I'm going to perform another GET request, and I'm getting an error here. Let me see what's the error. Album object has no attribute track. So let me go back to the serializer. So the name here is track, and if I go check the models, oh okay, the related name here tracks, so I'm supposed to name this here tracks to refer to that related name. So if I save this and wait for the server to rerun, and then go back to the Postman and perform a GET request, as you see now, I get the two album objects, and inside the first album object I could simply see that I managed to get the tracks, which is a list of 3 tracks that I linked to the album 1, and they are represented inside the album object. And that was easily achieved by simply adding one line of code here and using the string related field to get the related object to this album. Hello everyone, in this tutorial we will create a custom user model, and the reason why we would do that is because we need to extend our user model and have more control on it. At the moment the user model is basically just a username, email, password, and we need to add more to that. And in order to do that we need to create a new app in our Django project and name it, for example, users app. So let's do that. First, let's activate the virtual environment. And then let's navigate to our project folder, my API, and inside here we need to start the new app, which is the user or users app. And to do that we can basically say python manage.py start app, and we'll name it users app, or I think user app will be okay. And if you notice here, we managed to create a new app which contains the necessary folders and files. So now to start structuring our custom user model, let's go to models.py, and inside here we need 2 classes. First one is the user manager, and that will inherit from base user manager. And the second class is the user class. And this will inherit from abstract, base user, and permissions mixin. Okay. So the first class is responsible for the user object creation and the fields needed for that. And the second one is basically the user model, or the fields that we need to add to the user model. So let's start with our user manager class. And inside the user manager class, let's create a private method, which is the create user method, that will handle the user creation. So we'll type create user, and inside here we'll add all the necessary arguments that are needed for the user creation. Okay, so we'll start by username, sorry for that, email, password, and we can specify some fields like for example, if this user is a staff member, is the user super user, or is the user active, not active. So we can specify that also here. So we can basically add more fields like is active, for example, or is staff, and is super user. And at the end, we'll add an argument for extra fields that we might need to add to this user. Okay, and inside this method, let's do some validation and specify some information. So say first let's check if the user is valid, and to do that we can simply say if not user, which means if the user is not provided, we need to raise an error, which is a type or value error. Okay, so we'll say value error, and we'll say the given in user name is not valid. Okay, and the second field we need to check, or argument that we need to check, is the email. So email equal, and we need to use something called normalize email, and that will convert all the domain part of the email to lowercase. And now we can create the user by saying, or the user model, by saying user equals self-did model, and inside here we can specify the arguments. So we say username equal username, email equals email, and we're gonna skip the password now, because we can use another way to set the password outside of the model, outside of this function here. So we can set the other specifications, like is this user active? So we choose to decide if it's active now or not. So maybe we can just leave the user, or the user won't be active until they verify their email. Then we set this field to active, and for example, or you can put it true, and the user will be active immediately. This is just some, let's say, a checkpoint for you, where you can instead, for example, after you create the user, let's say the user is not using your website anymore. So instead of deleting the user from your database, you can simply set this field into false, which means the user is inactive. Or while the user is active, you can this field is like true. So you choose what to do with this. For example, the second or the other field or argument is staff equal, and then is super user equal is super user. So basically here we're just adding the arguments, and then we can specify some other fields here. For example, we can add the time when this user joined the website or signed up for the website. And to do that, we can just simply say, for example, date joined, and then we can, let's say, equal, for example, now, and then we specify now here, now equal time zone dot now. Okay, so this will give us the time, the actual time, and the last argument will be the extra fields. Okay, so now after we created the user the user object, we need to set the password dot set password, and this will take password as argument, and then we save the object user dot save. We specify this using the database. Okay, and then we return the user object. So the private method that we created is I think it's complete now. So what we did, basically, we specified the arguments that we need for the user creation, and then we did some validation in it. We created the user object model with the needed fields or necessary fields, and then we set up the password, and then we saved the object and returned the object. So in order to use this private method, we need to call it from a normal method inside our user manager class, and to do that we simply define a new method we call create user, and this method will take a username, email, password, and the extra field argument. And inside the create user method, we need to call our private create user method, and then return the result or the user object created there. So basically we can say return self create user, and then we pass the argument username, password or email. Let's start the email, password. We can specify that is this user or is active. For example, if is active, then we set up this, for example, is active equal true. Is it staff equals, it's not staff, false. And is super user, and that's false as well. And let's check the sequence here. So username, password, yeah, is active, is staff, is super user, and then at the end we add the extra field. So I think that's it. I think that will do the job. Let's save this. So now we have the actual method to create the user, and we added the arguments that needed here. So this method will create a user, a normal user, like in the scenario where the user signs up to your service or website. This method here will be used. What we need to use now, what if we need to create a super user as in our API? So we need to define another method to create a super user, and this will take some arguments as well, like username, email, password, and extra fields. And inside here we'll say user equal, we'll use the private method create user and here we'll specify the username, email, password, and we'll simply say that this user is active, true, and is stuff true. For example, is super user true, because this is a super user that we're creating. And we mustn't forget the extra fields argument. Okay, so after that we need to save this object. And then we return the user object. Okay, so with that being done, I think we're done with creating the user manager class, which will be responsible for creating a new user and creating a super user as well. Okay, what's next? Let's head to the user class, and now let's add the user model fields inside the user class. And to do that, let's start by username, and the username is a char field, so we're gonna say models dot char field, and we'll specify the maximum length, which is let's say 30, for example, and then we'll say it's unique, and that means like two users, we can't have two users with the same username. Okay, and after that, the second field we can add the email, and it's an email field, so it's models.email field, and inside the email fields we can specify the maximum length, which is going to be 250, for example, and it has to be unique. Okay, after that we can add like first name equal it's a chart field as well, and that will take maximum length 30. We can specify some other stuff here. For example, the user doesn't have to have first name and last name, so we need to add blank true, null true, because this field is not a crucial field. I mean, the user is not obligated to add a first name and last name. In this case we can make it otherwise. Last name, do the same. Blank true, null true. And what else can we add? Okay, we can add the is active, and it's a boolean field, because is active, it's either it's true or false, so it's a boolean field, and we can add the default to false, or let's keep it true. Let's have a true as a default value, is staff. Also boolean, and by default it's false. Is super user. Also boolean, and the default value is false. And so what other fields we can add here? We can add, for example, the date joined, the date that the user joined, and it's a date and time field, and we can give it a default value of time zone dot now. And what else we can add? We can add, for example, another boolean, like for example receive newsletter, for example. Okay, we can simply say receive newsletter, and we can specify this as a boolean, and we can, like, ask the user if they want to receive a newsletter from our website, and if yes, then we change this value. What else we can add? We can add birth date, or the date of birth, and this is also date time field. And I think we should, because these are not compulsory, we should add like blank true, null true. We can do this also on the top. I'm just gonna copy, paste this. This is okay, this is okay, this is okay. Okay, let's leave it this way. What else we can add? For example, address. We can add address 1, address 2. We'll just say address for now, and it's a char field or character field, and we can specify the maximum length, for example 300, and paste this. It's not compulsory. Yeah, we can add other stuff, like for example phone number, for example. Okay, we can add like city, for example, city. We can add as much as we need to add or to specify about the user, and basically we just need to specify the fields, and all the extra fields here that we added, we are able to add it because also as you remember, we added extra fields here, so which means these fields are included plus the extra fields that we might add in our model. So basically we can add as much fields as we want to specify or to have more information, store more information about the user. We can add, like for example, about me, and this, I'll put this also blank and null. About me, for example, we can specify like text field. Okay, it will be like, for example, let's say 500, and yeah, so we managed to add more fields, have more control on our user class or user model. What else I'm thinking of is like we can add even an profile image. And this will be models dot image field, and we'll set it to null true. Okay, so these are the fields that I could think of at the moment. You can edit it, you can add whatever you want. The next thing we need to do is to create an object instance of the user manager, and by doing that, objects equal the user manager class. And next we need to specify some settings variable, like the username field, and which is the user name, must be small letter, and we need to specify the required fields for the user object. The required fields is a list that we need to add, and for now I think email is the most important thing. And I think that's it, guys, for the user class. So we can save it now. After saving that, after we create the user manager and user class, let's import the necessary classes here, like base user manager and abstract user base. And to do that, we need to type this from so let's import it from Django.contrib.auth.models. We need to import permissions maximum, and I think I misspelled it here. Yeah. Okay, and then let's import the base user manager Django.contrib
base user manager
and abstract base user. So these are the main. The other thing we need to import is the time zone. So from Django.utils import time zone. Okay, because we needed to create the drawn date. Let's save this file. So I think that will do it. The next thing we need to do is we need to go to our setting .py, the project settings file, and specify and tell our project or API that we need to use this model here as our user model. Okay, so how to do that? Let's go to settings. So here inside the settings.py, we scroll down. First, let's add the user app to our apps here. So to make sure it will be installed, and let's head to the bottom here and specify the auth user model. So we'll need to type auth user. Okay, let's make it all capital. Auth user model, and it must be the user app dot user, and that tells the API that we need to use the auth user model from the user app dot user, which means it'll go to the user app, which is here, and then it'll go to the models and use this user here, user class. Okay, and after that, inside Rest Framework here, we need to add the serializer. Okay, so what we need to do is type here user details serializer. Okay, and this will tell our API to use the serializer and the app that we created. So it's inside user app, so lowercase user app dot serializer dot, and serializer will be, I'll name it user details serializer. So it's user details serializer. So I think we should go create the serializer now. Okay, let's save it, and let's go to our user app. Let's create the serializer.py here, new file. And inside here, I'm just gonna copy and paste the code just to save time, because there are a lot of typing here, and then I explain what's going on. So first thing first, we have two classes here, the register serializer and the user details serializer. This user details serializer will be used to serialize the data that we post and get from into our API, and the register serializer will be used when we register a new user. Okay, so inside here, as we see, we specify the normal fields using the serializer from Rest Framework, and we specified the email, which is the email field, and we said we pass here an argument saying, so required here, if it's required or not required, that depends on the settings. Okay, so this argument here, if we just copy this and we move to our settings and we go here and specify that account email required, and then we set this to true or false, whatever we put here is what will be the settings for the email field. Okay, first name, second name, also we can specify if they are required, not required, if they are write only, write read, all that restrictions that we can put to each field of the fields that we can or we need to add here. Okay, we can add more fields. Like as I will edit here, first name, last name, address. I can add the city. I can do the restrictions. Okay, any of the fields that we use in our user model. Password 1, password 2 are required as well, because you need to provide password and verify the password. What else? Then we have some validation methods. So first one will be validating the password to see if the password is it short, does it contain for example only numbers, or does it have numbers with characters? So is it a common password or not? This will be validated here, and according to that we raise an error or a warning or other messages to the user. And inside validate also we can validate if the password 1 equal, or does it equal password 2, so because both passwords must match. And if not, we can raise a validation error as you see here, and send it back to the user. And custom sign up, we're not going to address this in this tutorial, so we can get rid of it. And the get cleaned data will give us all the data from the fields, or the cleaned or validated data. And then we had to save in the serializer save method. And the save method is what's happening here simply is we creating a user object, and then we using the adapter to get a clean data, and then after that we save the user object through a request, and we return the object. That's it. That's all. And inside the user details serializer, we specify the user model and the meta class meta, which is user, and the fields that we need to our serializer to deal with when we perform a post or get request or other requests. And these are the fields that we added there, basically the first name, last name, address 1, 2. I didn't add address 1, 2. Maybe I should delete this. Let's check the model. I added only address, so we can add the address. Phone number, I didn't add it, so you can add it, guys. Country, city, all that stuff you can add. I added city, about me, profile picture, also zip code. All these guys are fields that you can add there and then use it. But I'm gonna keep it short here, and basically that's the serializer. And now, guys, let's add the user model to the admin.py. So let's import it first from .models user, and then we register it admin.site.register, and we put the user and we save. So now, after we created the user manager, the user model, and we edit the settings to refer to the new user model that we'll be using, and we told our REST framework that the user details serializer will be in the user app directory serializer file, and added the app to our installed apps. Now what we need to do next is to run the make migrations and migrate to set up the database and add the new user table there, and then we can run the server and go to the admin panel and see the user there and how the configurations and code that we wrote reflected in our API. So let's do that. So we'll do python manage.py missed E here, and as we see, created user model or model user, and then now we migrate. And as we see, all the tables have been created. And now that we ran the migrations and we know that our custom user model table has been created in the database, let's create a super user and try to log in. So we type python manage.py create super user. And let's give it a name, admin, and email admin at myapi.com. Let's set a password. Let's verify the password. And now that the super user has been created successfully, let's run the server. And let's go to the browser and try to log in. Okay, let's navigate to the admin and let's say admin. Let's put the password, and here we go. We managed to log in with the super user that we created. And if we look here down, we see the user app that we created, and inside here we can check the users. And this here is the admin user, and if we go add user, we can see here that we have extended the user model into more practical and more advanced user model. And as we see here, we have all the fields that we added into our custom user model, like as the first name, last name, as active staff, and as super user, plus the date joined. And we also the receive newsletter, birth date, all of this useful information about our user now is accessible and editable. So that's it guys for this tutorial. I hope it was useful and you learned something new. And if you have any question, please leave it in the comment below. I try to make it as short as possible. Hello everyone, in this tutorial we will see how can we improve our API performance and achieve a seamless user experience using multi-threading. And why would we need to use multi-threading in our API? Well, the reason is that sometimes we need to perform a time-consuming tasks in our project. Like for example, sending an email, or maybe doing some calculations and behind the scene, or maybe you're running an AI model that requires some processing or data processing in the backend before storing or updating some data in your database. For example, if your project requires an image recognition, and that's considered a time-consuming task, so that should be handled differently. Also, let's say your project is handling a social media web app or a mobile application, and when someone uploaded or posted a new post or video or anything, picture, you want to send notification or maybe email the related users to that to that particular post, then you might need to send like hundreds of emails or messages to some users, and that can't be handled normally as a normal function in our, for example, view method, or like view create method, or update method, or any other method. So it needs to be handled as a task, as a thread, so it doesn't cause any delay or lagging in our API performance. So to demonstrate that, I'm going to use one of the applications that we created previously in this series, which is posts, to send an email every time I create a new post. And the first approach, or the first thing we would think of, is to create a method inside our posts view set, which will handle the email send whenever I create a new post. And inside the create method here, we will just call this function after we save the new post that we receive from the API client. So let's do that first and see how can we improve that. So I'm going to come here inside this post view set class, and I'm going to create a method. I'm going to name this method send email. Okay, and inside this method we will send the email. So this method will take as arguments the message or the email body. So let's keep it as message, then the subject of the email, and also the recipient list. So the recipient list is the list of emails that we need to send this message to. And inside here we can use send mail from Django mails, which is I previously imported here. So from Django.core.mail we import send mail, and we're gonna use it here. So inside here we need to add one more argument for the send mail, which is from mail or from email. So I'm gonna add it here, which is, this is my email. And now we can use the send mail here. So first thing, we add the subject, then the message. After that we add the from mail or from email. After that we add the recipient list, which is, I'm gonna copy from here. And the last thing we add is the fail silently, and set it to false. So this will send the mail or the email for us. Bear in mind that this function here won't work if we don't add some settings to our settings.py, our project settings.py, for handling the email, which is I'm going to show you at the end of this video. So let's save this for now. And the next thing we're going to do is we're going to call this function here inside our create method. So after a new post dot save, we need to call self dot send email, and then we need to pass the arguments. So the message will be, for example, this is a notification. Let's just name it that. And after that the this first takes message subject, then the subject will be notification, and then we'll add the recipient list. So I'm gonna add the same email here. So I'll be sending an email to myself, which is okay, and that should do it. So let's save that and let's run our server. Please make sure your virtual environment is activated. So I'm gonna type here python manage.py run server, and after that I'm gonna go to the browser and navigate to the post URL and try to add a new post. So let me open the browser. Inside here I'm gonna go to post/posts and click enter. And as you see, these are the previous posts that we added. So I'm gonna add a new post here, and I have email opened here, so it's gonna show me if I receive any new email. So I'm gonna add the post here. Let's say hello from API, and the post body will be like for example, this is the post body, and now I'm gonna click post, and as you see here, it's still processing. So what it was doing, it received the post request, and then after that it executed the send email function and waited until the send email is completed, then sent me back the response. So that was for one email, and you saw that it took like 2 to 3 seconds. Imagine if you're sending like 400 or 1000 email, if you have that big application. The delay will be like in minutes or maybe hours, so we don't need that. And if we go check our email now, we can see that I received a new email here. Let me just expand this, saying this is a notification. Okay, so which means working is just not the best approach, or not the right approach for that. So let's use now multi-threading to improve the API performance and get better user experience. In order to do that, I'm going to create a new class here, and I'm going to name it handle notifications, for example. And this will inherit from threading or threading.thread. Obviously we need to import threading, and inside here I'm going to define an initiate method init, and this method will take self as an argument plus all the email arguments that we used previously with the send email method here. So I'm just gonna copy them and paste them here, and inside the init method I'm just gonna get these arguments here. So I'm just gonna say self dot message equals message, and then self dot subject, will do the same for the rest, equal subject, and self dot recipient list equals recipient list. And then I will initialize the thread. So I'm going to type threadings.thread.initialize, and then I'll pass the self as an argument. One more method we need to add, which is the run method. So this method will get executed when we call the class.start. So inside the run method, I'm going to perform the send mail. So I'm just going to copy this from here and paste it here because it's going to be the same thing. And I'm going to add self to subject, message, and recipient. And that will get us these variables here. So, and from email will be this variable here, because this is not going to change, so I didn't pass it as an argument. But the recipient list might change. I might change and add different emails. So I think this should do it. So I'm going to save this, and inside the post view set, instead of calling the send mail or send email method, I'm going to comment this out, and underneath I'm going to call the handle notification class and pass the arguments that we previously passed here to the send email function. So I'm going to copy them and paste them here, and then I'm going to add .start to trigger the run method, and this should do the work. So let me save this and then go to the browser, and inside the browser I'm just gonna perform another post request. So I'm just gonna edit this and say, for example, add to, and here this is a post body 2, and then perform a post request. But before that, I want you guys to notice that the difference between the delay for the response to come from the API. So in the previous request, we noticed that we had a delay like for 2-3 seconds before we got back the response. But now if we perform a post request, which is I'm gonna do now, we'll see if I click post, I'll see I get back the response immediately from our API, and now at the meanwhile the thread is executing the send mail to send an email to the user. So if we go my email here, I'll see that I received a new email here which says this is a notification. So it did the same work, but we got a better performance and more seamless user experience from our API. And this applies on many use cases, as I mentioned before. So before we end this tutorial, I just want to show you guys the settings that we need to add to our settings.py file in our project in order to get the email to work. So these are the variables that we need to provide. So first one is the email backend, which is from Django. The email host is the smtp.gmail because I'm using Gmail mail server. And then comes the username or the email host user. This is your email, and the email host password. This either can be your email password or password. For example, if using Gmail, you can create a new app for your project, and then you will get a specific key or password which you can edit here, and then you add the port and the TLS option. So yeah, that's it, and then you can start sending emails. Obviously this will change if you're using another mail server or another account. Hello everyone, in this tutorial we will see how can we schedule a task in our Django Rest Framework API and get it to run in the background. And there are a lot of use cases for that. One of them is, let's say you want to send a newsletter to your users or to your subscribers every week. Okay, you can do that. Let's say you want to back up your database or your data every day at maybe certain time. You can do that. Another use case for that is connecting to an external services or APIs to collect some data and then maybe store it in our database or use it for some other functionalities. And this is what we're gonna do in this tutorial in order to see how schedule works. So for that I created an application inside our project and I named it weather using Python manage.py start app weather. And what we need this application to do is to connect to external API that holds weather data, fetch this data and store it in our database so we can use it in our own way in the future. So basically, if we go to the models.py, I created a model here. I named it forecast. It has a simple 4 fields, which is the timestamp, temperature, description and city. So we'll be getting the temperature and the description of the weather for a specific city. Okay, and in the views.py I simply created a view set, a weather view set that will serve the requests through the URL, which is weather /data, because I added here in the root urls.py. So this is it here, it's included. And in the serializer I added a serializer for that model that will help us serialize the data. So at this stage we'll be able to communicate with this application, save data or get data. And if I run the server now, obviously guys, after you create this, please run make migrations and then migrate and then run the server. I did that already, so I'm just gonna run the server. And I'll wait for the server to run. Then I'm gonna go to the Postman, and if I perform a GET request, I'll see I still have nothing in the database. So we're not gonna store anything in the database manually. We'll just handle this through our scheduled function, which will go and get the data from the weather API and then store it in the database. Then we'll be able to see it here when we perform a GET request. And for that I'm going to use a service called let me just open the browser. It's called Open Weather Map, and this will give me an API endpoint where I can use to get the weather data of a specific city. So after you sign up for this, I'll leave a link in the description for this website. After you sign up here, you will get an API key which will allow you to perform the requests. Obviously there's a limit for how many requests you make per minute, but you can also buy one of their plans. It's a very nice service. So here I can see here the APIs or API call, and what's the requirement here? The requirement here is for example the city name and the API key, or the city name, the state code, and API key, and that's what I'm gonna use. So first I'm gonna try to do a request using Postman and see what type of data I can get from this API. So let's do that. So this is the API that I'm going to use. I'm going to use the weather of London, and then I provided the key for the API, and then I'm just going to send a GET request. And as you see here, I get a lot of data about the weather. So I'm going to choose some of these fields here or objects to store in our database, which is, for example, the city, the temperature, and the description. So I'll get the description from here, and the city name from here, and I'll get the temperature from here. Okay, so it's in Fahrenheit. We can easily, transfer it or convert it into Celsius. It's fine. So this is what I'm going to get from this API. And the next step is to find a way to perform a GET request to this API inside a function in our view, and then take the response, extract the data from it, and then save it in our database. So let's do that. So if we go back to VS Code, inside our, I'm gonna do it inside views.py. You can do it however you want. You can add these functions, but I don't want you guys to get confused in case you're using model view set before to serve your application, and then you want to add this functionality to your API. Then you can do it within your view class. You don't have to add extra files and other stuff. So for doing requests, let's cancel or close the server. We need to install requests package. So it's pip install requests. That will help us to perform requests to APIs. And after that, inside our views.py, we need to import requests. I already imported here. The next thing we need to do is declare a function inside our view set. Let's name it, for example, get weather data. And this is going to be a private function. So we'll pass self here, and inside here, let's declare a variable called URL, and this will be the URL for our call. And then let's use requests to perform a GET request to this URL. So let's declare another variable. Let's name it API requests equal requests that we imported dot get, and then we'll pass the URL, and then we'll check if the request is successful. Then we'll return the response data. If not, we'll return none. So we'll wrap this in a try except. So here we'll say API request dot raise for status. This function will tell us if the request was successful, and if yes, then we'll return API requests.json. If not, we'll just return none. Okay. None. So let's add the URL here. I'm just gonna copy it from our request here and the postman. Obviously you can make this dynamic, but for the purpose of this tutorial I'm just gonna keep it static. So instead of putting this as a static here inside inside the URL, you can just make it as a variable, and then the key as well, and then you can use .format to insert this variable into the URL string. The next thing we need to do is extract the data that we need from the API response and then save it into our database. So to do that, let's declare a function or a method, and we'll name it save data, and or save weather data, and this will take self as an argument, and then inside this method we will say, for example, weather data equals, we will call the private function get weather data, and then we will check if the response is not none. So if weather data is not none, then what we'll do, we'll wrap this in a try except, and then we'll create a new object of the data. So we'll say weather object, for example, equals we'll take the forecast model name dot objects dot create, and then we'll pass the fields or the key value of the fields that we have in our model. So we'll start by the temperature, which is equal the weather data, and then if we check the response here, so the temperature is within the main, so it's going to be weather data main then temp. Okay, so we'll do that, main and then temp. The next argument will be the description, so equals weather data, and let's check the response again. The description is within the weather, so weather is the list, so we'll take the first list, which is 0, then we'll take description. So it's going to be like this, weather data 0, then description. The last argument is the city, so city will be, let's check, will be just the name. Okay, so it's in this object, it's represented by the key name, so I'll just add weather data name, and that should work. And then after that we will save this object, so weather data dot save, and then we'll say accept we're not going to do anything, we'll just pass. Okay, so when we call this function, what will happen, or this method, what will happen is this method will call the getWeatherData, and then this method will return a response with the weather data. We'll extract it and save it in the database. The next thing we need to do is to set up the scheduler. So to do that, first I'm going to install the AP scheduler. So I'm going to use pip install AP scheduler. After that, I'm going to create a folder inside the weather application, and I will name it weather schedule. And inside this folder, I'm going to add a new file, which is the init file.py, which is going to allow us to see this folder as a module where we can import inside our files. So the other file that I need to create here, I'll name it, for example, updater or weather updater .py. Inside weather updater, I'm gonna first import the background scheduler from AP scheduler. So I'm gonna do that now. So from AP scheduler dot schedulers dot background import background scheduler, and then I want to use the schedule to run the save weather data inside our view set. So the weather view set, so I need to import that here. So let me import from weather app dot views import weather view set. And after that, I'm going to declare a function, and I'll name it, you can name it whatever you want. I'll name it start, for example, to start the schedule. So I'm going to declare this function, so start, and inside this function I'll first get an instant of the background schedule. So I'll just say scheduler equals background scheduler, and then I'll also get an instant of the weather view set. So I'll just say weather equals weather view set. So after we initialize the scheduler here, we need to assign or add a job to the scheduler. And to do that, we can simply say scheduler dot add job, and then inside here we'll specify the function that we need to execute, and which is the weather dot save data. And then after that, we'll specify the trigger for the job. And the AP schedule has three types of triggers: interval, date, and count. So the interval will allow us to execute a function or execute a job in a specific interval time, okay? Like every 5 minutes, every 3 minutes, 2 minutes, every 30 minutes, it doesn't matter. The date will allow us to execute this job in specific date. okay, that we specify. The cron will allow us to perform or execute the job periodically in a specific time of the day. So we're gonna go for the interval for now, and I'll leave a link in the description for the documentation. You must check it out if you want to know more or get to use more functionality with the scheduler. Definitely there are a lot to know there, and it's pretty interesting. So let's choose the interval, and then after that we need to specify the interval value. So for now I want it to be like 2 minutes, so we'll type minutes equals 2, and then we need to give this job an ID. So we'll just say ID equal, for example, weather 001. And then one more thing we need to add to prevent the schedule from creating a copy of the job each time the application restarts. We can simply add replace existing true. So that's for adding the job. After that, we can simply say schedule dot start to start the schedule. So this is the main setup, okay, for the schedule. And now that we configured the scheduler, we need to call the start function when the application runs in order to get the schedule to start. So in order to do that, we will go to the apps.py inside our application, and inside the weather class we need to, or the weather config class, we need to declare a method called ready, and this method will get called when the application is running and ready. So inside here we need to first import the weather updater. So what we're going to do is we're going to say from weather scheduler import weather updater, and then we can call the start function. So weather updater dot start, and I'm going to add a print statement here just to show you guys when it's getting called. So I'm going to say print, and then here I'm just going to say for example launching or starting scheduler. Okay, so this will run or will get called when the application runs and is ready. So the start function inside the weather updater will get called, and that will start our scheduler. Okay, let's run the server and see how it's gonna go. So I'm gonna just type here python manage.py run server. Or before that, I just want to see when we get the response from the API. So I'm going to add a print statement inside our views as well. So here I'm going to print the weather data. We will see it in the terminal when we get weather data, and yeah, that should be okay. And inside the weather updater, I think I'm gonna put this into 1 minute just to make it faster and save it. And now we can run the server. And it's telling me the no module name weather scheduler. So okay, let's just go to the apps.py, just add a dot here to tell it to get it from the root directory. Okay, I have another error here that says background schedule. Oh, okay, I misspelled this, so it's background, and here as well. Okay, now that the server is running, we should get a response from the weather API within the interval that we set here in our scheduler, and then after that response get received, the function inside views.py should extract the data from it and then save it in our database. And after that, we should perform a GET request to the endpoint of our application and be able to see some objects as a response. So as you see, guys, here we get a response back from the API, and this response has the data that we wanted. So let's perform a GET request and see if the data got saved. And we see that we have no data. So let's check why. So I'm going to close the server and go back to views.py and see if I did extract the data correctly. So this main temperature, so it's main temperature, and then the second argument is the description, which is weather data. Oh, okay, I think I made a mistake here, because it's weather data, weather, then the description. So I need to add this here. Okay, so I'm gonna add this here, save it, and then rerun the server. One thing, guys, we need to note here, as you see, I have starting schedule twice, and we need to avoid that. And the reason why that's happening, because when we run the server again, it creates another instance of our application or project. So in order to avoid that, we need to add the no reload after run server. So that should do it. So now we should see only one starting scheduler, and then we will wait until we get the response from the API and see if the data gets saved. And here we go, guys, we got our first response from the weather API, and now let's check if the data was saved. So I'm going to perform a GET request to the link, and as you see here, we have our first object saved. So that's cool. Let's wait for another response and see if another object will get saved. And I chose to save or create an object every time we receive a new response. We can also update the existing object or the existing table in our database as well. So this is up to you guys. So I received another response here, so I'm gonna send another request, and as you see, guys, I have two objects now. So it's pretty cool that we managed to do this in the background without having to call this function every time we needed to update our weather data in our database. And there are many use cases for this, and I highly recommend, guys, that you check the documentation. I'm going to leave a link in the description for that, so you can learn more about schedule. Hello everyone, in this tutorial we are going to deploy our Django Rest Framework to one of the platforms that's very popular and easy to use, which is Heroku. And to do that we need to do some configurations and add some files to our projects. So without further ado, let's start. So first thing first, let's start a new terminal and activate our virtual environment. And because the virtual environment folder is in the parent folder of our project folder, so I'm gonna just go back and then activate it from here. Scripts, activate, and then after that I'm just gonna go back to our project folder, which is my API, and inside here I need to initiate get, because we are going to use get to deploy our project to Heroku. So to do that we just need to say or type get init, and that will initialize an empty Git repository in this folder. After that we need to create a file inside our project folder, and I'll name it .getignore. And inside here we need to specify the folders and files that we want Git to ignore when deploying to Heroku. So to do that we need to add first the visual or VS Code folder here. So we just need to type .vs code, and underneath also we need to ignore the database, the SQLite database. So we can just simply say star.sqlite. And what else we need to ignore? We need to ignore some of the files inside each application we created, like the PYC files. So we need to add this one here as well, .pyc. And I think that's enough. If you have your virtual environment folder inside your project folder, then you need to add it here. So I think that's enough for git ignore. Now we can add the project files to and folders to Git. So we just need to say git add and dot to add all, and then we're gonna do our first commit. So git commit, and then we can name it first commit. That's fine, and that will add all the folders and files to to Git. After that we need to hide our secret key, because if you look here, it's not recommended, or it's risky to deploy your project with an exposed secret key as you see here. It's just a plain text. So what we need to do is we need to use a library called Python decouple to hide the secret key. And maybe it's not only the secret key. If you have like an email password, if you have you're using AWS to store your files, you need to hide your key, AWS key and password. All that you can use with the Python decouple. So to do that, let's first install Python decouple, and we're going to use pip for that. So pip install Python -decouple. So I already installed it. You guys can install it. And to use Python decouple, we can simply before we import it, Python decouple uses a file called .env. So we need to create this file here, .env. Inside this file here, we need to store our keys or passwords. So I'm just going to copy this from here, or maybe cut it from here, because we don't need it inside our settings.py anymore. So I'm going to paste it here. So here I have the secret key and I have the debug. I'm going to save this inside this file and go back to settings. Inside settings, I need to import config. So from decouple, import config. And I'm going to use config to get the secret key. So I can basically type secret key equals config and then pass the secret key as a key. So I'll just type here secret key. Okay, and same thing goes for debug. So I can just type debug equals config, and I can either bust as a key only, or I can give it let me type it first. Also, I can give it a default value. So I can just say, for example, default equals false, and then I can give it another argument, which is cast equals pool. So it's a boolean. So that's for the secret key and debug. Okay, so now we know that the secret key for our project is protected. The other thing we need to configure or change is the database URL. At the moment, in the development environment or in our local host, we're using SQLite, okay, and it's within our directory. So we need to configure that for it to work on Heroku or online on other servers. So to do that, we need to use a library called Django database URL. So let's install it first. Pip install Django database URL. After we install Django database URL, we need to use it inside our settings.py. So let's import it first. So from Django database URL, import parse. Okay. So we need to use parse to point out the URL for the database. At the moment, the database is pointing to the main directory here and to the db.sqlite database here file. So what we need to do, we need to comment this out like this, and then and after that we need to create something called default URL. Okay, so default database URL. So to do that, let's say default db URL equals, and this will add first the SQLite. So we'll just type SQLite, and then after that we're just here building the URL for the database. So we use a plus sign, and then we're gonna add the directory of our project. So it's os.path.join, and then inside here we can use the base directory, which is base dir, and then the name of the database, okay, which is db.sqlite. Okay, 3. So if you look here, this is the base directory, okay, which points to the directory of our project. So after we create the default database URL, we need to add the database variable. So we simply type database equals, and this will be an object, and this object has a key default, and the value will be the config if we're storing our database in our in the env file here. So let's add it just in case you guys want to store it in future. So we can simply say config parentheses and type database URL here, URL, sorry, and we need to give it a default value, which is the default URL or default database URL, and then we can give it a cast of we can choose the cast to be parse. Okay, that's it. That's all you need to configure your database. So let's save this. And after configuring the database, we need to handle the static files. And to do that, we need to use a library called Django Static. Okay, so let's install this library. Pip install Django Static. Okay, so after installing Django Static, we need to go to the WSGI file here, and then inside the WSGI file we need to import from let's type it first, from Django Static import cling. Okay, we need to use cling. We need to wrap our application or WSGI application with cling. So we can add it here, and that will handle static files for us. One more thing we need to add for the static files to work is to go to settings and add a static root. Okay, so at the moment we have a static URL. We need to add static root, and this equal to we need to specify the directory of the static files. So what we can do is os.path, sorry, it's capital letter, os.path.join, and then inside here we use the base directory, and then the name of the folder will be static files. Okay, so that should do it. So let's save this now, and then the next step is to create requirements.txt file. Okay, and inside the requirements.txt file will store all the libraries that we used in our project. So when Heroku looks at our folder or our project, look for the requirements.txt file in order to know what packages and libraries needs to be installed. And to do that, first we need to create requirements-dev txt file, and that will include all the packages that we needed for development. So let's simply type pip freeze, and then we write the name of the file, which is requirements-dev.txt. And as you see here, that generated requirements.dev.txt, and if we open it, we can see all the packages that we used in our project. So the next step is to create another file and name it requirements.txt. So the server will look at this file, not at this file. This file is for our development environment, and this file is where Heroku will look for this file, requirements.txt. So inside requirements.txt, we need to add the server that we're going to use, or Heroku will use, which is a G-unicorn. Okay, so why we separated them? We separated them because we don't want to add the G-unicorn server, which is going to be used only by Heroku, to our requirements.dev file, because this requirements.dev is for development, and we don't need the G-unicorn here. So that's why we created another file, and inside here we're going to implement all the requirements-dev content plus the G-unicorn. So in order to do that, we're going to type here -r to read the requirements-dev content. Okay, and underneath we need to add the G-unicorn. Okay, so I'm going to add that underneath. Okay, also here we can add the packages and maybe dependencies that also needed in the deployment stage. Okay, so let's save this. The next thing we need to do is create a proc file inside our project folder, and please make sure it's a capital P. Okay, and inside the proc file we need to specify the web server, which is the G-unicorn, and add the name of our project to it. So we'll simply say web, and we'll add G-unicorn, and after that we'll add the name or the directory for our WSGI folder, which is my API.WSGI. In your case, if you're creating another project, another API name, you need to replace this my API with the name of your main project. Okay, and after that we need to add the log file, and space dash. Okay, so let's save this for the proc file. After that we need to create another file called runtime, and inside this file we will specify the version of Python that we are using. So at the moment we're using Python 3.7, so we can specify here the version of Python by typing Python dash 3.7.10, and the reason why I used 3.7.10 because there are specific releases of Python that are supported on Heroku. So to verify that, or to know what is supported, you can simply go to the website, or their website, and then if you go to Heroku Python support, you can see that the versions or the releases of Python that are supported by Heroku. So you can see here you have a 2.7.18, 3.6, 13, 7, 10, 8, 8, and 9, 2. Also, it depends on what do you use. You can simply change the Python version inside your runtime file. Okay. The next thing, after we created all these folders, files, and changed the configuration, we need to go to Heroku and create an application there. So I'm going to go to Heroku. You can, if you don't have an account, you can create an account. It's free. And then after you create an account, you'll find yourself inside this dashboard where you can add new or create new projects. So I'm going to go here for new, create a new app, and we have to give it a name. So you can name it anything you want. I'm just going to name it Django-Test dash API. Okay, and I can see it's available. I can simply go create an app, and as you see here, the app was created for me. And inside deploy, we have to go to deploy. Inside deploy, I can specify the way I want to deploy my application or my project to Heroku. One of them is through Git, and that will require a Heroku CLI to be installed. The other way is using GitHub or using containers. So in this example, we're using Git for simplicity, and for that we need to install or download Heroku CLI. So you can just simply click on Heroku CLI, choose your, it depends on your operating system, if you're using Windows, Mac OS, or Linux, install the Heroku CLI, and then simply after that we can use it inside our project. So I'm going to go back here to my app, and before starting or before we could use Heroku CLI, we need to log in, okay, using Heroku login. So I'm going to copy this and go to the terminal. Inside here, I'll just need to clear this and then type Heroku login, and it'll ask me to open this in the browser. So press enter, it opens in the browser, and inside here I can log in. So I've already logged in before, that's why it says logged in. For you guys, if it's your first time, it's going to ask you for your email and password. You enter them and log in. After that, you close the browser and you find yourself logged in here. Okay. After that, let's go back to our application, and you can see that there are some instructions here on how to use Git to push or to deploy your project. So first, Git init, which we already did. So after that, we need to use Heroku CLI to get access to the app repository. So let's copy this line here, go to the terminal. We already did Git init, we already initialized it, but if you didn't, you should do it. And then we can type Heroku git remote, and if you notice here, this is the API, the app name that we created on Heroku. We press enter and wait for it to finish. After that, we need to add all the files, then commit, then we can push our project to the Heroku master branch. Okay, so to do that, first I'm going to type get add dot to add all the files that we have, and then get commit, and then let's name this first deploy, and then enter. After that, we need to disable the collect static, and that's sometimes you need it, sometimes you don't, but from my experience it's better if you disable it and do it manually, because sometimes it gives error on first deploy. So to do that, I'm just gonna type Heroku config, and I want to set disable collect statics equals 1. So I'm going to do that, disable collect static equals 1. Okay, after doing this, now I need to push my project to Heroku repository. So what I need to do is, if I go here, look, I can use the git push Heroku master, and then as you see here, it's pushing it pushed my project to Heroku, and now it's installing packages that I have for my project. And as you see, guys, it says deployed to Heroku, and then verifying deploy done. So the next step, or the next thing I need to do, is run the migrate to create all the necessary tables on Heroku database. So to do that, I'm just going to type Heroku, okay, small letter, Heroku run python manage .py migrate, and now the migrate will start. And as you notice, any command that I need to run on the server or Heroku server for my project, it needs to start with Heroku. So I can see here I got an error. It says please supply engine value, check settings documentation for more details. So I think I have I did some mistakes here configuring the database. So let's check here if everything is alright. So I think I changed instead of using parse, I changed it to I create an alias which is dp URL, and I added, I think, a comma here to make sure everything is alright. Saved it, and then let's try again. Just any change you need. If you want to deploy, you need to add, and then commit again, and then deploy. Or let's say push. So I'm gonna push the files again to Heroku, and then I'm gonna try to run the migration. So I'll wait for it to finish. And I can see deployed to Heroku. Now after that says verifying done, then I'm going to try to run the migrate again. So I'm just going to run the migrate now. And wait for it to connect. And as you see now, it's running the migrate. So it's building all the database with the tables as we configured or programmed. And as the migrate is done, now I can create a super user on the server or on Heroku by simply typing Heroku run python manage.py create super user. Okay, so I'm going to choose a name for it and a password, and then we're going to go to Heroku, try to access everything from the browser. Okay, so everything should be online. Okay, let me type the name. Let's say admin, email admin@myapi.com, for example, and I'll choose a password and confirm the password. And super user created successfully. One more thing we need to add before we access our project or our API online is we need to add the new domain to allowed hosts. So to do that, I'm just gonna go to the Heroku app, and inside here, if I go to settings, this will be my domain. Okay, if I click this domain now, I try to access it, it'll tell me that invalid HTTP host header, because this is not included in the allowed hosts. So I'm going to copy this and go to settings and add this to the allowed hosts list. So I'm going to paste it here, save, and then I'm just gonna push again our files to the server. I can commit, and I can give this commit a name, says update allowed hosts, and then I can perform push to Heroku, and after that I should be able to access the API and then get to the admin panel. So now that the deploy is done, I need to go here and refresh this page, and as you see, I have access to my API. Okay, so if I want to go to the admin panel, just type admin, and as you see here, my API is running online. I have the login for the admin, so I'm going to type admin and then the password. And as you see now, I have access to all the tables and models that I already have in my project, and I can edit them. I can add new data, remove data, delete data. I can do whatever I could do in my local host. So as you see, guys, we managed to deploy our API in just a few steps, and it was easy and was like kind of straightforward, because Heroku is one of the easiest ways to deploy and test your projects. And there are many settings and configurations that you can use with Heroku, and I highly recommend that you go through them and read the documentations and learn more about it, because it's very handy and simple and easy to use. So that's it, guys, for this tutorial. I hope it was useful. If you have any questions or if you have any issues with deploying to Heroku, just leave your question in the comments and I'll help you with that. Hello everyone, in this tutorial we will deploy our Django Rest Framework API project to AWS or Amazon Web Service. And in order to do that, I created a copy of our project. I moved it into a new folder and I opened it in VS Code. The only thing I kept is the get-ignore file, which includes the files and folders that we need to ignore, not push to the server, and the requirements.txt, which includes all dependencies and libraries that our project requires. The next step is to create a virtual environment. So I'm going to open the terminal, and inside the terminal I'm going to type virtual env, and I'm going to name the virtual environment eb-virt. We're naming it like this because we are using AWS Elastic Beanstalk, and EB stands for that. You can name the virtual environment anything, but just to refer to Elastic Beanstalk, we need to name it this way. And then I'm going to execute this. I'm going to wait for the virtual environment creation process, and then after that I'm going to install all the dependencies that are inside the requirements.txt, and then we run the server, make sure everything is running or working fine. After that we proceed with the Elastic Beanstalk configurations for Django Rest Framework project. So now that the virtual environment is created, let me activate it by /ab-virt/scripts, then activate. And now that's the virtual environment is activated, I can install all the dependencies by typing pip install -r, then requirements.txt. So it's complaining about one library called handslap, which I think we don't need. I'm gonna delete this library from here, save, and then perform the pip install again. And now that all dependencies are installed, let's run the server and see if we're missing any step or if there's anything not working. So I'm just gonna type python manage.py run server, and it's telling me the decouple module not found, so I have to install this library. So it's pip install, I think the name is python decouple. Okay, that's installed. Let's run the server again. And the Django database URL is not installed, so let's install it. URL, and it's installed. And now it's telling me that the symbol JWT is not installed, so we have to install it. Pip install, I think it's Django Rest Framework dash symbol JWT. Hope I'm right. Okay, that's installed. Let's run the server and see if there's anything else wrong. Okay, it seems that I have a problem with my API WSG application, so let's take a look. Oh, okay, it's the Django statics, so I need to install that as well. So pip install Django statics or static, and now everything should work fine. Okay, now my server, Django server, is working. So now that I know I missed a few libraries that I had to install later, let me add this to the requirements to txt by typing pip freeze and then requirements to txt, and that's added. So now I'm gonna run my server again. Okay, so now that the server is running, we know our project is working 100%. So the next step is to configure our Django Rest Framework project for Elastic Beanstalk deployment. And in order to achieve that, first thing first, we need to have an AWS account. So if you don't have an account or you're not signed up with AWS, I suggest you go to the AWS website and sign up, and then you can follow up with me. I already have an account, so I'm just gonna sign in. And now that I'm in the AWS website, so I need to go to services and either look here for Elastic Beanstalk like this, or if you already used it before, it's going to show on the recent services. Okay, so after going to Elastic Beanstalk console, you'll see this dashboard here is where we can monitor and configure our deployed project. But before we get to this stage, we need to deploy and create an environment for our project on Elastic Beanstalk service. So in order to do that, there's a few requirements. So I'm gonna go to the documentation of AWS for deploying Django application with Elastic Beanstalk. So as you see here, in the deploying a Django application to Elastic Beanstalk, if you look at the requirements, we need a Python 3.6 or later, which we have. We need pip, virtual environment, and AWS CLI. So we already have most of the requirements. We just need to install AWS EB CLI, which is AWS Elastic Beans CLIs. So if we go to their guide for installing it, we can see it's pretty simple to install it. So we just need to use pip install AWS EB CLI. And if we go to our project, so let's install it first inside our virtual environment. And then we can deactivate our virtual environment and install it globally. Okay, so I'm gonna run pip install AWS CLI. And now that's this done, we need to go back to the documentation. And if you go step by step here with the documentation, you will see that most of these steps we've done already, like creating a virtual environment, activating it, installing Django, creating a Django project, and also starting a project and running the server, making sure everything works fine. We already have all that, so we're gonna skip to the configure your project application for Elastic Beanstalk. And for that, we first need to activate our virtual environment, then create the requirements or add all the dependencies to requirements.txt, which we already did. And then we're going to start here from the step number 3, which is creating an EB extensions folder. So let's do that now. And as you see now, I have an EB extensions folder. Inside this EB extension folder, we need to create a Django configuration file, which is Django config, and add some configurations to it. So I'm going to create a new file here, name it Django config, and I'm going to copy the configurations from here to this file. And if you notice, this configuration is just telling the AWS Elastic Beanstalk where is our application's WSGI path. Okay, so we're gonna change this name to our project name, which is my API. So I'm gonna type my API here, and that's all. After that, if we go back to the documentations, the next step is to deactivate our virtual environment and then initialize the Elastic Beanstalk CLI. So to create an environment and deploy our Django Rest Framework project or application to Elastic Beanstalk on AWS, we need to first initialize the EB CLI. Okay, so let's copy this comment here and then go to the terminal and paste it here in the terminal. And this comment here will initialize the EB CLI and create a new project for us. So in this comment, we get to choose the name of the project. So I'm going to name it My API. Okay. And then we get to choose the version of Python that we need to use. And I'm going to use the Python 3.7. And I'm going to hit enter. And now this application was created. Let's go back to the documentation and see the next step. The next step is optional, which is EB init or initiate. And with this, I can set up an SSH if I want. But in this case, now for the purpose of this tutorial, I don't want to do that. So I'm just going to skip this step. The next step is to create an environment and deploy the application to Elastic Beanstalk. So to do that, we need to copy this comment here and then execute it inside our terminal, but let's change the name of our environment to My API -env. Okay, and then hit enter. And now, as you see, AWS or Elastic Beanstalk service is creating our application. And now that the process of creating the environment and deploying is done, we can see that create environment operation is complete, but with errors. So in order to know, and also you could know from this here summary, it says successful 0, failed 1. So the deployment has failed. In order to know why, the only way is to go to your console and the AWS website and then refresh. And as you see here, inside environments, you have My API environment. So if you click on My API env, as you see here, the health is pending, and you can see here you have some errors, the events of environment creation. So to know what caused this error, we need to go to the logs here under my API env to request logs. We can ask for full logs, or we can just request the last 100 lines and see if that helps at the beginning. So we download it, and as you see here, it was first installing or downloading the dependencies, and the error occurred during execution of a command. So if we follow here, we could see that this library, which is the database library, is causing this issue. So what we need to do is we need to exclude this one from our requirements.txt and test. Pingfig is required to build this. So this is all for Postgres database. So to solve this for now, we need to go to our project, requirements.txt, and then exclude it because we're not using Postgres database at the moment. So I'm just gonna comment this out, save. And let me check if anything else here might cause a problem on the AWS server. And I can see there are two dependencies here that might cause problem. The PyPy when 32 and the PyWhen 32. These two libraries are not required for AWS deployment because we are using, or AWS is using, Linux as its operating systems, as we see here in a moment. So it's running on Linux. So these two libraries also might cause problems, so I need to comment them out. And then now I need to save this changes and then try creating a new environment. I can't create the same environment name, so I'm going to change it to my API-env-1 and then execute. And now we just need to wait for AWS or Elastic Beanstalk to create the new environment for us. And now, as you see, instance deployment completed successfully, and successfully launched environment my API-env-1. So now I need to go to my console and then refresh. Let me choose the environment that I want. And as you see here, this is the previous environment, which is failed. And we can now terminate this environment because it has failed and we don't want to keep it. So here I need to type the name of the environment, which is my API-env, and then terminate. I'll leave it to terminate and I'll go to the working environment, which is my API-env-1. And as you see, health is okay. And I have no errors here. And if I go to the link, this is the link for my project after deployment. So if I click on it, I can see that my project is working and it has been deployed successfully. The only problem here is that I didn't add this domain to the allowed host in my project. So I'm gonna do that. There are two ways to do that. Either I copy this from here and add it to allowed hosts, or I can go to my project terminal and just write ep status. That will give me the status of my project, and copy the CNAME from here, and then go to settings.py inside our project, and then allowed hosts, and then edit here. So now how to upload or deploy my project again after the changes that I've done? It's pretty simple. We just need to type ep deploy. But before that, I want to check the git ignore file here to make sure I added, and you guys mustn't forget this, you have to include here your virtual environment folder, because you don't need to push the virtual environment folder to AWS. So I'm just going to add it here, save git ignore, and then deploy. So I'm going to execute the ep deploy. One thing to notice here, that every time I deploy my project, it creates a new application or a new version of my application. So if I do some mistakes, or if it happens that I deployed a version with a problem, I can always go back to the previous version and activate the previous application. Now we're gonna wait for it to upload. And it's saying here invalid parameters value error. So it's saying no environment found for environment name. And it's good that this happened. So when I created this environment, you remember my API inv has failed, and we had to create a new one called my API inv-1. But now when I did the deploy again, it used the old environment. So how to change that? To change that, we need to go to this folder here, Elastic Beanstalk, and inside here there is a config.yaml file. And if you look here, the variable here, this environment, has a value which is my API-inv, which is the old environment. So we need to change that to -1 and save it. Also from this configuration files here, you can change your Python version, you can change your region where you are, and then deploy. And after changing the environment name, I need to check the status to get the CNAME so I can add it to allowed host. So I'm just going to type ap status. And I'll take the CNAME from here, copy it, and then go to settings.py and change this and save it. After that, I can run the deploy. And now it's going to create a new version of my application with the new configurations. And now that the environment has been updated successfully, let's go to the AWS, close this and refresh to see if everything is working fine and I have no errors. And now that I have no errors, let me just go to this link, and as you see now, my API has been deployed successfully and I could see all the links there. And if I go to the admin, I can see now my admin login is available. And in order to do the migrations and create a super user, we need to do that on the local host. Here, for example, we need to first activate our virtual environment, which is eb-virt/script/activate, and then after that we can run python manage.py make migrations, and then migrate, and then after that we can create a super user. So python manage.py create super user, and we'll name it admin. This username is already taken, so I guess because I copied the database SQLite from the original folder, so it's still saved. So let me try to port this process and then log in the website or in the API. So if I can type here admin and then the password, and as you see, I'm logged in. Okay, and I can control my API, I can do whatever I want, and it's all deployed to AWS. But if you didn't have the admin or super user created, you can simply create it on the local host and then deploy again to AWS, and you will be able to access your admin panel from there. Some important things to note when using AWS services. First, AWS charges you for using instance, or for the instance that your project uses on their platform, like the EC2, the load balancer, and other services. So if you're using or you're testing, you're deploying to AWS to test only, make sure after you finish testing, make sure you terminate your environment. Don't just keep it running and forget about it, because you will come after 1 or 2, 3 months and you will find that you have like $100 bill or $200 bill, and you don't need that. Another thing is, if you want to use it and you decided that you're going to use Elastic Beans, Stack, or you want to use other AWS services, make sure you are familiar with Cost Explorer that they have. Okay, and if you go to their services and you check, they have AWS Cost Explorer, which will give you all the information you need to know about how much money your project is costing you, or your deploy or is consuming from AWS resources. Okay, and then you can adjust your costs, and you can ask or configure AWS to give you notification when your cost exceeds certain limits, so you can keep your resources under control, or you can turn them off, turn them on during specific periods. So that's very important to note. The other thing is, if also you work with Elastic Beanstalk, let's say you did some changes to your projects and then you deployed, and then after deploying you found out that there's a big problem in your project and things went wrong. You can simply go to applications and choose your application name, which is, for example, my API. And then if you come here to application versions, you can see all the versions that you've deployed, and you can simply choose which one you want active. Okay, for example, if this is the last one you deployed and then something was wrong with this version, you can simply activate the previous one and then fix the problems, then deploy again, so you will have no downtime. Also, you can delete the old versions if you don't need them, for example, and then you can simply go to actions, delete them. Okay, you don't need these old versions, so you don't have too much data occupying your S3 bucket. Okay, you can also download your project files from here. It's a zip code, you just click on it and download it, and you can see all your files. One more thing to mention is now in this stage, the database that we are using is the SQLite database, which is the same database that we have on our local host. You can simply change that by going to your environment configurations and choose another database like Postgres or MySQL or any other database here by editing this field here. But if it's not necessary, don't do it, because you will get extra charges for using a database instance on AWS. Okay, but it comes with advantages, like you can always create backups of your database or instance of your database, so you can use it again, or you know, keep it, save it, and also it's more secure. But still, if you don't need it in your use case, don't use it, because it'll add extra cost to your project. So these are the main notes that I wanted to share with you guys. I hope I gave you enough information to start with, and if you have any question, please leave them in the comment and I'll be happy to help.